In the last class, we were discussing about what topic we have discussed: vector space, subspace, linearly independent set, linearly dependent set, linear independent set, and what is the basis dimensions. And also we have discussed the linear transformations, range space, null space, basic, and some of the basic of the matrices like eigenvalues and eigenvectors. I think most of the problem you have in eigenvalues, eigenvectors. Yes or no? You were saying, sir, eigenvalues, eigenvectors, we have some problem. You have problem in diagonalization. You have some problem in similar matrix, this kind of things. You have problem. Okay.
Hello.
Yes.
Sir, actually, I have a little problem in vector space. That's very little problem. Uh, I have a matrix of 2 cross 2. Okay, sir.
Mm-hmm.
And if it's A11 plus A22 is equals to 0.
2 cross 2 matrix.
Yes, sir. And A11 plus A22 is always equal to 0 coming. It's a set of matrix actually.
Mm-hmm.
It is a set of matrix. And the elements, other elements, I mean, all the elements are from the complex number. So do I have to check it with respect to addition for closure property?
A21 and A12. Basically, all are complex numbers. So you
Yes,
are
sir.
saying, I
Yes.
can write down here. This is W is the set of all 2 cross 2 matrix
Mm.
Aij such that A11 plus A22 0
Mm.
and Aij belongs to complex number.
Yes.
So you can say this problem is nothing but the problem of set of all 2 cross 2 matrix from M to C. M to C is
Oh, yes. Yes.
all 2 cross 2 matrix
Mm.
with complex entry. With complex entry, such that you are saying such that A11 plus A22 is 0. You can write that. Now vector space, basically whatever space you have, like whatever space you have, every time you apply additions operations which is defined, not multiplication operation. कहीं भी किसी भी वेक्टर स्पेस में कहीं मल्टीप्लाई लिखा हुआ है कि दिस इज फर्स्ट ऑपरेशन मल्टीप्लाई?
No, sir. It's not written like usual addition and multiplication, scalar multiplication actually.
Yes, usual addition and multiplication, because vectors, if you define vector multiplication are of two kind. One is of scalar, one is of like vector. So that's why they have not defined in the vector space the vector multiplications, because this vector multiplication is not unique. Then you have to define what kind of vector multiplication you are thinking. And there is one more thing also. In vector space, you are not multiplying, though you have a property in which you are not multiplying vector to vector. You are just, what you are doing in the vector space, you have some sorry, you have some space like R2, R3. If this is a vector, you are multiplying this vector by scalar. Scalar means you are increasing the length of the vector only. You are decreasing the length of the vector. Okay. You have two vector and you will add the vectors like this. You are addition of two vectors. You are not doing any other thing. Am I clear?
Yes, sir. Clear, clear. And actually, this set has a subset, and in which addition given, that is A12 plus A21 conjugate is 0, then still it is a vector space. No?
Check. Whatever property you are saying, whatever property you want to take, you have to prove that A alpha plus B beta must be belongs to A alpha plus B beta.
Yes.
A alpha plus B beta, like you have this problem. If you are saying W is Aij 2 cross 2, and that is belongs to M2C. A11 plus A2 is 0. So let A equal A and B belongs to what is this? W. So A equal to Aij 2 cross 2.
Sir, no, one extra information is also given.
Wait. Yeah. Add the information. What is the information?
The information is A12 plus A21 conjugate.
Like this, no?
Yes, sir, is 0.
Okay, no problem. So you are saying, so this is the condition. So if you take B matrix, in B matrix also A11, B22, B12 plus. So just think if you have A plus B, let us consider you have A plus B. So what is the A plus B kind of matrix? Nothing you have to prove. Very simple problem. You are saying the sum of diagonal is 0, yes or no?
Yes, sir, it will be 0.
Because this plus this is 0.
Yes, yes.
The same is you are asking me A12 plus A21. A12 मतलब A12 है ना,
Mhm.
plus A21 conjugate, and you know these two are complex number and conjugate you can separate. If you can separate, there is no problem. So this plus this 0, this plus this 0, finally 0. So addition vector is okay. In the same manner, you can multiply by vector also. Scalar, yes or no? Second property, A alpha. A alpha is
Yes, yes, sir. That's what I think. But the in the answer, it's saying that W is not a vector space over C. It's only vector space over R only. I mean, at this vectors.
So send me the exact question. What is the exact question? If somebody is saying this is a entries from C,
Hmm.
if you are taking entries from C,
Yes,
so
sir.
if you are taking entries from C, then what you are saying? All these entries Aij are complex number.
Yes, sir.
Yes or no?
Hmm.
Aij is complex number. Aij complex number. So these are the M2C is a vector space. M2C is a vector space. Okay. M2C is a vector space.
Yes.
So that is so this W is a set of all elements from M to C such that this condition satisfy. And
Yes,
you
sir.
know that the addition this condition satisfy. Okay, we will check. Wait, this is satisfy or not? Maybe this is not satisfy. First of all, wait. Second property I have to check. This is A12. So A11 maybe not satisfy. So we will say this is not okay. A11, A12, A21, A22. So if you multiply, you will get A11, A12, A21, A22. So if you take diagonal sum, so this is diagonal. So A into 0 is 0. Okay. If you take this thing, A12 plus A21. If you multiply by this, so basically, see what is the problem? Yes, A12. Yes, this is not a subspace. Huh? This is subspace or not?
It's saying that it is not subspace under C, but it may be under R, I think. If elements will be from R,
This
then
is right because see, when you take here, see here, A12 plus A21, if you take bar, so this is called conjugate because A can be complex number. Now this is also field of complex number.
yes. True.
So this will create a problem here. Okay, this is A bar, A21 bar. Now you cannot add these things. If A bar is real,
Yes.
A bar is real, sorry, A is real, then A bar is also real. A bar real, A bar is equal to A, then you can take outside, this will be the, so this is a, you cannot say, see, just think,
Yes, sir.
if somebody say this is a subspace over the field of real number, see, this is something wrong. मतलब थोड़ा ये भी wrong होगा, क्यों wrong होगा? One side you are saying you are taking a set of all matrices which are complex matrices, and you are taking set of all matrices over the field of complex number. Then you have to define. देखो इस क्वेश्चन में थोड़ा सा आपको क्वेश्चन जहां लिखा हुआ है मुझे एक्सेप्ट दिखाना होगा, ये सब स्पेस नहीं है, यस ये सब स्पेस नहीं है, ओके, बट ये चीज तो तुम्हें M2C से ही लेनी होगी. दिस इज फ्रॉम M2C. अगर कह दोगे कि मैट्रिक्स भी रियल नंबर है, फिर तो हमारी पुरानी प्रॉब्लम बन गई. ये लिखना होगा W is a set of all 2 cross 2 matrix
Yes.
from where all the entries are from complex number such that A11 plus A21 is equal to 0 and A12 plus A21 bar is equal to 0. Then W is not a subspace over the field of complex number. But if you take scalar or filled as, ठीक है ना, scalar or filled as a real number, because A12 plus A bar A21 bar cannot be 0. If you take A is real, then A bar is A, then A will be outside, then this will be the 0, so this will be the subspace. थोड़ा अलग टाइप की प्रॉब्लम हो गई है.
यस सर, वही तो थोड़ा सा अलग सा लगा ना, तो मैंने कहा चलो पूछ लेता हूँ.
योर नेम?
माय नेम इज चेत नारायण.
ओके.
तो सर मतलब आपने कहा जैसे क्वेश्चन भेज देना मेरे को, तो मतलब अभी कोई ऐसा तरीका कि अभी आपके पास पहुंच जाएगा
अभी
क्वेश्चन अगर
पहुंच
भेज
जाएगा, वो आप एडुंकल सपोर्ट टीम से कह दो. सपोर्ट टीम पे आपका मैसेज, एक नंबर होगा आपके पास.
हाँ जी है
ना, उसमें लिख दो कि काइंडली सेंड दिस क्वेश्चन राइट नाउ.
ओके.
So they will send.
अच्छा, ठीक है सर. I'll try.
Any other problem, student? Any other student are facing any problem? Because the main thing is, if you have any problems, चलिए तुम आगे चलो.
Yes sir.
So now matrices, we have discussed what is matrices and what is eigenvalue. See, eigenvalue and eigenvector are very important. Eigenvalue and eigenvector. So we have discussed some problem. You have what is eigenvalue, what is eigenvector, है ना? So if A is a matrix and AX equal to lambda x, you say X is non-zero. X is 0 is also eigenvector of every matrix, but we are going to find out all those x such that AX equal to lambda x, which x not equal to 0. यहाँ से हमारे पास आ जाता है A minus lambda I determinate is 0. सभी को पता है यहाँ से, because AX minus A minus lambda I x equal to 0. Non-zero solution कब आएगा? Because if we have determinate 0. Okay, so this is a characteristic polynomial, sorry, characteristic equation. If you take Ax equal to characteristic polynomial, if you take Ax equal to A minus lambda determinate is characteristic polynomial, and if you take this is characteristic equation. And Cayley-Hamilton theorem says every square matrix satisfies its characteristic equations. So every square matrix satisfy इट्स कैरेक्टरिस्टिक इक्वेशन, यस और नो? मतलब सबसे पहली बात ये है कि एवरी स्क्वायर मैट्रिक्स सेटिस्फाई इट्स कैरेक्टरिस्टिक इक्वेशन, अपनी ही कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करता है, यस और नो? सो ऐसा नहीं किसी और कैरेक्टरिस्टिक इक्वेशन को सेटिस्फाई करेगा, यस? So if you have a problem A, let us consider you have a problem A and A is of 3 cross 3 matrix, such that I am taking A is this kind of matrix. You know this is a diagonal matrix, and diagonal matrix has eigenvalue as the diagonal element. So our diagonal is 1 1 2. So we can say lambda minus 1 ka whole square and lambda minus 2 is the characteristic polynomial. Okay, in characteristic polynomial, and you know that characteristic polynomial, say if you take this is f lambda, so f of a is equal to a minus I ka whole square and a minus 2i. This will be 0. So what is the meaning of this? The meaning of this is correct, this polynomial is annihilate, this polynomial is annihilate by this polynomial annihilate by a. So this polynomial is called the annihilator, annihilator polynomial, annihilating polynomial. Annihilate मतलब annihilate polynomial. What is the meaning of annihilating polynomial? If you have a polynomial and you are putting a in place of lambda, then f a must be 0. It means ये एक तरीके से जिसे हम कहते हैं ना, lambda is equal to 1 is a characteristic root. Lambda is equal to 1 of is the root of this equation, है ना? It means lambda is equal to 1 annihilate the polynomial. In the same way, if you say this f lambda is lambda minus 1 ka whole square lambda minus 2, then Cayley-Hamilton theorem says this is the annihilating polynomial. And the question is, can you have more than one annihilating polynomial? Can you have more than one annihilating polynomial? मेरी बात समझना जरा. Yes, is it clear? Can you have more than one annihilating polynomial? कोई बताएगा मुझे? Yes or no? A minus 2i. A minus 2i is annihilating polynomial. Just Pranshu. A minus 2i is an annihilating polynomial. See, what is the meaning of annihilating polynomial? See, first of all, I want to tell you, because this is very important concept. That's why I am just revising this concept. First of all, I am if the matrix satisfied, its characteristic polynomial is annihilating polynomial. If a matrix satisfies its characteristic polynomial. See, what is the meaning of annihilating polynomial? No, there are so many annihilating polynomials. So this is one of the annihilating polynomial. Thanu, see, if matrix satisfy a polynomial, the polynomial is called annihilating polynomial. Okay, but how to find annihilating polynomial? What kind of polynomial are annihilating? See, first of all, we are going to discuss number one. Let us consider you have this problem, same problem, matrix A. Yes, yes. सभी बताऊंगा, दोनों combine कर रहा हूँ. You have this matrix A of 3 by 3 matrix, and you have characteristic polynomial f lambda is lambda minus 1 ka whole square and lambda minus 2. See, done. Wait for annihilating point.
Sir, wait, sir, just a minute.
सर तब तक मैं कुछ पूछ सकता हूँ क्या?
Mm-hmm.
जैसे अगर आपने कल लीनियर ट्रांसफॉर्मेशन के बारे में थोड़ा सा बताया था, लाइक हम लीनियर ट्रांसफॉर्मेशन को मैट्रिक्स में कन्वर्ट कर लेते हैं, है ना सर? तो अगर कोई लीनियर ट्रांसफॉर्मेशन का आप डायरेक्ट मैट्रिक्स ही ओनली दे रखा है सिर्फ, तो हम मतलब कैसे उसको बता सकते हैं कि वो 1 1 है 1 2 है,
जस्ट
लाइक उसके रैंक से, राइट ना?
बताता हूँ, अभी क्वेश्चन करा के बता देता हूँ अभी, है ना?
जी जी ठीक है।
इज इट क्लियर जिनेश? चलिए देखो, मैं थोड़ा क्लियर से थोड़ा और क्लियरिटी बताता हूँ. दिस इज ए कैरेक्टरिस्टिक पॉलिनोमियल. This is a characteristic polynomial. Okay. Now, first of all, forget about any leading polynomial. Now, first of all, we are discussing minimal polynomial. This is very, very important. They're very confusing how to find out the minimal polynomial. Lambda minus 1 का whole square, lambda minus 2 is a characteristic polynomial. So question is, a polynomial, देखो मैं लिख रहा हूं, minimal polynomial is what? Minimal polynomial number 1, g minimal polynomial का नाम रख रहा हूं मैं, that is g lambda. Minimal polynomial g lambda. So what is g lambda and how to find out g lambda? Number 1, g lambda divide f lambda. Am I clear? Minimal polynomial is a polynomial which divide annihilating polynomial, sorry, which divide characteristic polynomial. Number 1. Number 2, g lambda has same root as characteristic polynomial. मतलब ऐसा नहीं है basically कि if you are going to find out the minimal polynomial, and what you will do, you will say, sir, I will take minimal polynomial which do not have characteristic, which do not have root lambda is equal to 2. So this is not possible. Number 3, g lambda is of minimum degree such that g of a equal to 0. So we have these conditions. मतलब सबसे पहले कि you have g lambda divide f lambda. Okay. So what are the possibilities here? G lambda divide f lambda and g lambda has same root. See, f lambda खुद एक मिनिमल पॉलिनोमियल हो सकता है. G lambda is equal to f lambda. That is lambda minus 1 का whole square, because this is only the possibility. Second is g lambda can be, देखो ये हो गया 3 डिग्री का polynomial. 2 degree polynomial. What is the possibility of 2 degree polynomial? Lambda minus 1, lambda minus 2. You cannot say. Can you say कि lambda minus 1 का whole square is a minimal polynomial? That is not possible. Why? Because we have said g lambda divide f lambda. Number 2, g lambda has same root as characteristic polynomial. So root you cannot ignore. You can ignore only algebraic multiplicity. You can decrease the algebraic multiplicity. You cannot ignore the root of the characteristic polynomial. This is also clear. Next is g lambda is minimum degree such that g. So it means we have only these two possibility. We have these two possibility. Yes or no? So first of all, whenever you have some like characteristic polynomials, then you have to find out what are the possibility of the characteristic polynomial, so that we can find out the minimal polynomial. So there are two possibilities. So in first possibility, you know g lambda is 0. Sorry, g a is 0, because g lambda is, in first case, this is a characteristic polynomial. So in characteristic polynomial, you will say this is always annihilating by. This is always annihilating by. Annihilating matlab, if you put a in g, sorry, in a in place of lambda in g lambda, that will be 0. So this is also 0. So can you say this is also 0? Ga here, this is 0 or not? Lambda minus 1, lambda minus 2. This is 0 or not? This matrix. Can you please check? See, if you take in this matrix, you know The matrix A is 1 0 0 0 1 0 0 0 2. This is a diagonal matrix. This is a very simple matrix. If you take A minus I, so the matrix is 0 0 0 0 0 0 0 0 2. If you take A minus 2I, so the matrix is A minus 2I 0 0 0 0. Yes or no? So basically, if you multiply this and this, yes or no? Yes. Yes. So if you multiply this, then what you will get? This is a diagonal and this is a diagonal. Diagonal matrix multiply. How you will multiply diagonal matrix?
सर 1 minus 1 is
Wait,
सर आपने
wait.
मिस्टेक करी ये इधर a minus I में लास्ट 2 नहीं होगा सर
Yes. ठीक है. So diagonal matrix, how to multiply diagonal matrix? You will multiply by corresponding diagonal element only. So finally, you will get the answer is only 0 0 0 0 0 0 0 0 0. Done? Yes or no? Am I clear?
Yes, sir.
So the point is you have to find out the answer. Okay, you have to find out the answer by this. This is simple question. This is simple question. And what is the minimal polynomial? Then this is the minimal polynomial. So if you take some other example also, so you have to understand if any polynomial which is characteristic polynomial, you have second polynomial which you are saying minimal has three properties. First property is that will be divisor of f lambda. Okay, it means you cannot say कि minimal polynomial is lambda minus 1 का whole square, lambda minus 1, lambda minus 3. You cannot put some other like factors. Only factors are from here, and both the factor must be here in the g lambda because this is the same root as root of the characteristic polynomial, and you have to find out the minimum degree, which minimum degree means this is degree 3 annihilate, this is degree 2 annihilate, degree 1 is not possible. So degree 2 is the minimum which annihilate, which divide, and which has same root as a characteristic root. Okay, so this is called the minimal polynomial. So is it clear ki what is the minimal polynomial? Yes. If I give you some problem, see, if you have a matrix, yes, a minus 2i मतलब सारी diagonal element -1 है. क्यों भाई? This is -1 ना? Yes. So this is upper triangle matrix. This is UT. What is characteristic polynomial? Because eigenvalue are UT and UT are upper triangular, lower triangular, diagonal, scalar matrix. All the eigenvalues are for the diagonal elements. So lambda minus 1 ka whole square and lambda minus 2, 3. So what is minimal polynomial? What is minimal polynomial? Please find out in this matrix. मैं यहाँ से इसे भी जीरो नहीं करता हूँ. I am giving 1 here. Okay, all this one. Minimal polynomial possibility is only 2. एक तो यही होगा, and second one is you can check lambda minus 1, lambda minus. So you have to check only this. If this is not, then this is answer. If this is yes, then this is only the answer. So check a minus, whether a minus I and a minus 2i, 3i. Product is 0. See, this is 0, 2, 1, 0, 0, 2, and 0, 0, 1. This is 3 minus 2, 2, 1, 0, minus 2, 2, and 0, 0, 3. What is the product? Please find out what is the product.
This is not, sir. This is not the.
not 0. No?
Yes, sir. This is not 0.
So this is not 0. It means you cannot say this is annihilate. And the polynomial which is having degree less than 2 also not annihilate. So only two possibilities was there. This is not annihilate. So this is only the annihilating polynomial. So this is only the annihilating polynomial which has minimum degree, divisor, and annihilate. It means this is also a minimal polynomial. Done. Next question. Question is, if a matrix n cross n has all of eigenvalues as distinct, then characteristic polynomial is same as minimal polynomial. This is true or false? This is true because you have all the eigenvalues like lambda minus 1, lambda minus 2, lambda minus 3, lambda minus 4, and lambda minus 100. Let n is equal to 100. You have these roots. So characteristic polynomial is this. This is annihilating polynomial also, and the minimal polynomial is of minimum degree, which has all the roots. Only this. You cannot put power 1 as 0 because otherwise this root will be not there in a minimal polynomial. So there is no other polynomial which annihilate. Okay, this is only the polynomial. It means this is the minimal polynomial. Am I clear? Yes or no? Sorry. Now let us consider you have like 5 cross 5 matrix such that a lambda minus 1 की power 4 and lambda minus 2 is characteristic polynomial. Let us consider. ठीक है, lambda minus 1 की power 4 and lambda minus 2 is a characteristic polynomial. Just tell me what are the possibility of minimal polynomial. See, possibility 1 is this the possibility. Possibility is lambda minus 1 की power 3 lambda minus 2. Second possibility is lambda minus 1 का whole square lambda minus 2. And third possibility is lambda minus 1 and lambda minus 2. Yes or no? These are the possibilities. And this is also one of the possibilities. This is also one of the possibilities. Let us consider this also. This polynomial is annihilate. It means that will be 0 by putting a. That is also putting, this is also 0, this is also 0 by putting a. So what is the minimal polynomial? What is the minimal polynomial? Last one. So this is the minimal polynomial. Okay. So this is the minimal polynomial. So what is the meaning of annihilating polynomial? See, this is the polynomial which is minimal. Okay. This is annihilating. Yes, this is annihilating. What is the meaning of annihilating? The meaning of annihilating is if you put any polynomial into a, then f is equal to 0. That is called annihilating polynomial. Done. This is also annihilating. This is also annihilating. This is also annihilating. This is also annihilating. But these are not only the annihilating polynomials. See, whenever you will have the annihilating polynomial, characteristic polynomial, you will find out any kind of this kind of polynomial which are like this is, let us consider this is not annihilating. This is like, this is not equal to 0. Let us consider this is not 0. मेरी बात समझ रहे हो? This is not 0, this is 0. Let us consider. मतलब this is feasible or not feasible. I'm not saying, I'm just giving a hypothetical example. This is not 0, this is 0. So this is not annihilating. Yes or no? This is annihilating, this is annihilating, this is annihilating. But by the help of these annihilating polynomials, you can create infinitely many annihilating polynomials. कैसे? If this is 0, you can multiply lambda minus 1, lambda minus 2, lambda minus 3. So this is also annihilating. Yes or no? Because this factor, if you multiply a minus 2i 0, if you multiply any factor of a, a minus something, and this 3 is not an eigenvalue or eigenvalue, we don't care. So this is also annihilating. So lambda minus 1, lambda minus 2, lambda minus 3 की power 5, and all these things you can say these are annihilating polynomials. So this is also annihilating polynomial. So you will multiply anything, this is also annihilating. You will multiply from this characteristic polynomial of degree higher, this is also annihilating. It means, what is the meaning of annihilating polynomial? A polynomial will satisfy a is called annihilating polynomial, but just remember my point. If you have a minimal polynomial, see, if you have minimal polynomial, okay, if you have minimal polynomial lambda minus 1, lambda minus 2, if you minimal polynomial में कुछ भी multiply करो, कुछ भी multiply, whatever you want, you can multiply in the minimal polynomial, whatever factor, that is called annihilating. That is called annihilating. पहले मेरी बात सुनो, please. If you have a minimal polynomial, whatever you will multiply, that is annihilating, because this is minimal is the smallest annihilating polynomial. Minimal polynomial is a annihilating polynomial of a minimum degree. इस minimum degree से कितनी भी डिग्री बनाते चले जाओ, yes or no, देखो ये डिग्री मिनिमम थी, इससे इतनी डिग्री बनाते चले जाओ, बढ़ाते चले जाओ, क्यों? Whatever multiply you will find out. सही है? lambda minus 1, lambda minus 2, lambda minus 1 का whole square, lambda minus 2, lambda minus 1 का cube, lambda minus 2, lambda minus 1 की power 4, lambda minus 2 की power 5, lambda minus 1 की power 4, lambda minus 2 की power 5, lambda minus 3 की power 7, lambda minus 4 की power something. So whatever you want, you can multiply, because automatically you have got the A matrix. This minimal, that is annihilating by A. So this is the annihilating polynomial. Minimal is the smallest annihilating polynomial. So is it clear? The annihilating polynomial is a polynomial. Very simple way. I am just explaining now. Annihilating polynomial is a polynomial which has characteristic root. उसके अंदर जो रूट होंगे ना, कैरेक्टरिस्टिक जरूर होंगे. देखो, अगर कोई मेरे से कह दे कि lambda minus 1 और lambda minus 3 is a annihilating, this is a annihilating polynomial, I will say no. Lambda minus 1 and lambda minus 3 is not annihilating polynomial. Annihilating polynomial is also a polynomial, which is a annihilating polynomial. I can say very simple language, let mx is a, let m lambda is a minimal polynomial, then for any polynomial g lambda, m lambda into g lambda is annihilating polynomial. Am I clear? This is one of the blunder मतलब एग्जाम में ब्लंडर कर देते हैं, हम गलती कर देते हैं, and then we regret after the exam. Yeah, this kind of things should not be there. सो मिनिमल में कुछ भी मल्टीप्लाई करते रहो, यू विल गेट एनिलेटिंग. Am I clear? Now Nathanu is saying, so all minimal are annihilating, but converse not true. Am I right? So all minimal, see, all minimal कैसे कह दोगे? Minimal is unique. Because what is minimal की searching है. Whatever we are doing, this is the searching of minimal. See, in this problem also, what we were doing, we were searching of minimum degree. These are not minimal. Going back. All minimal why? Minimal is minimum degree, that is unique. Annihilating polynomials are infinitely many, while minimal polynomial is unique. Am I clear? Yes or no? Yes. इस स्लाइड में मिस्टेक, कौन सी स्लाइड में मिस्टेक है भाई? तो मिस्टेक मत ढूंढो, छोटी छोटी जैसे कोई मिस प्रिंटिंग हो गई, दैट इज नॉट, कंसेप्ट इज क्लियर. कौन सी स्लाइड में मिस्टेक निकाली? Which slide you have mistake? This slide. Which slide you are?
Sir, previous. अभी आपने वो एक सम का बताया था. Yes sir.
Don't think यार ये क्या रहेगा ना? क्या मिस्टेक है इसमें? 0 0 3 minus 1 2. तो ये 0 है. ये तो मल्टीप्लाई कर लेना है. This is you can do multiply. ठीक है. हाँ, किसी को मिनिमल पॉलिनोमियल में डाउट है? Whatever doubt you have in minimal polynomial, characteristic polynomial, annihilating polynomial, you can ask right now, because ये बहुत बहुत important concepts है. जिसको जो भी डाउट है ना?
No doubt, sir. Everything's clear.
बताइए कोई भी डाउट.
सर मिनिमल पॉलिनोमियल को मतलब किस वे से, मतलब उसे अगर आप शॉर्ट में मतलब आपकी डेफिनेशन क्या रहती है सर उसकी, मतलब जैसे आप एक क्वेश्चन से एक बार बता दीजिए सर. कैरेक्टरिस्टिक आ गया सर, कैरेक्टरिस्टिक समझ में आ गया. कैरेक्टरिस्टिक
क्या बताया इतनी बड़ी कहानी क्या है? दिस इज अ मिनिमल. इसके डेफिनेशन क्या बताऊं? पूरा मिनिमल पे 15-20 मिनट हो गए बताते बताते. फिर 15-20 मिनट रिपीट करूं? बताइए.
कोई नहीं सर, वो वापस से रिकॉर्डिंग देख लेंगे ना.
सर कहने का मतलब ये है कि मतलब इसमें मतलब हमें क्या किस बात को ध्यान में रखना होता है अगर हमें मिनिमल पॉलिनोमियल को फाइंड आउट करना है?
This is the definition. Just go through once and let me know if you have any doubt.
अच्छा, ये डेफिनेशन है सर. ओके, एक सेकंड सर.
ये प्रॉब्लम्स करा रहे हैं, यही तो पूरा बना दिया इसका. बंडल्स ऑफ प्रॉब्लम्स वी हैव डिस्कस. डन.
ओके सर, समझ गए.
तुम एक्टिव नहीं हो उसका मतलब? कहाँ कोई कुछ काम कर रहे?
सर लिख रहा हूँ, लेकिन वो थोड़ी प्रीवियस स्लाइड के मेरे छूट गए थे तो वो बीच में स्किप हो गया सर, पहले का लिखने में.
So this is clear of the minimal polynomial. So there is one question. Let A is 2 cross 2 matrix such that A is 2 cross 2 matrix such that A square is I. That find trace of A. I am giving some problem to you for like this eigenvalue, eigenvector. Then you will ask whatever question you will have doubt. Okay. So A is 2 cross 2 matrix such that A square is equal to I. A monic polynomial way बताते हैं. Monic is nothing. Monic means the highest. Monic polynomial is a polynomial. Monic polynomial same as minimal polynomial. No. Monic polynomial is a polynomial which has highest coefficient. Highest degree coefficient is 1. Monic. मॉनिक पॉलिनोमियल में हाईएस्ट कोफिशिएंट। अच्छा, trace of a0, how, what is the concept you have applied? What is the concept you have applied? Just tell me what is the concept you are applying. Can you speak over the mic? What is the concept you are applying? Because I am very curious. Yes, what kind of concept you are using? Eigenvalue 1 and minus 1, how? Why eigenvalue is 1 and minus 1? Yes, Pratiksha, can you speak over mic? Just फटाफट बोल दो कि कैसे हुआ ये इनवॉल्यूंटरी मैट्रिक्स। अच्छा चलो, लेट
सर उस क्वेश्चन में ट्रेस 0 और 2 दोनों ही पॉसिबल है ना?
वेट, मैंने एक क्वेश्चन ही लिख दिया,
1 भी पॉसिबल।
यही तो प्रॉब्लम है, मुझे जो बतानी है ये बताना। इसका आंसर क्या होगा? A is 2 cross 2 matrix such that A cube is equal to I, then what, then find the trace of A. Yes. मैं समझ गया तुम क्या कर रहे हो।
सर कैन वी से एग्जैक्टली मतलब कि यही होगा? हम तो बस पॉसिबिलिटी बता सकते हैं ना कि ये और यही हो
मैं बस
सकता है।
मैं यही एक कुछ इसमें कुछ राज है, there is something hidden, so that's why I am going to discuss.
एक्चुअली वो तो डिपेंड करता है ना मैट्रिक्स के ऊपर, लाइक अगर मैट्रिक्स आइडेंटिटी मैट्रिक्स ही है।
Don't worry, I am just explaining this one. You are thinking in this manner कि A square is I, नहीं बस मतलब
if A is
so A square is I, you are saying it implies you are saying determinant of A is equal to 1, A square is 1 है ना? So you are saying determinant of A is 1, then determinant of A is a plus minus 1. So how to find out? You will say, sir, determinant plus minus 1, determinant of like determinant 1, you have taken possibility, then lambda is equal to 1 1 या फिर minus 1 or determinant minus 1, then 1 and minus 1. So you will have possibility sum is 0. Okay, the sum is 2 and sum is 0. So sum is like minus 2. So trace can be minus 2, trace can be 0, or trace can be 2. Yes or no? These are the possibility.
yes sir,
These are the possibility. Yes or no? Am I correct?
correct sir, correct.
But this is wrong. Actually the problem is कि 2 by 2 की मैट्रिक्स दी है, 2 by 2 की मैट्रिक्स दी है, and A square is I, and I have discussed to you कि characteristic every square matrix satisfies its characteristic equation. वो अपनी characteristic equation को satisfy करती, किसी और को नहीं करती। अगर 2 by 2 में ऐसा दिया है तो उसकी highest degree characteristic equation which is like you are thinking characteristic of degree 2, and degree 2 is lambda square minus 1. This is a polynomial which satisfy this, we can say. So this is the characteristic polynomial only. But in this case, this is what basically this is an annihilating polynomial. An annihilating polynomial of degree is exactly as the order of a matrix is a characteristic polynomial only. But in this case, if you say this is annihilating polynomial, yes. But in this case, you cannot give me answer of the annihilating polynomial, sorry, characteristic polynomial, because this polynomial is lambda minus 1, lambda minus omega, and lambda minus omega square. Basically अगर ये दोनों मेरे पास रूट हुए कैरेक्टरिस्टिक के तो मल्टीप्लाई करके 0 तो ये भी आ जाएगा, अगर ये दोनों हुए तो जब भी 0 आ जाएगा, और ये दोनों हुए जब भी 0 आ जाएगा. It means in this case we cannot say anything about what is the exactly characteristic polynomial and what are the exact value of eigenvalue. Okay, but in this case we are much sure about this is only the characteristic polynomial. So this is from the when we have understood the concept of characteristic polynomial, minimal polynomial, and annihilating polynomial. Characteristic, if you multiply anything, characteristic one kind of annihilating. You multiply anything, that will be the annihilating. And the degree which is less than characteristic is some polynomial which is annihilating, that is also characteristic. कुछ मेरी बात क्लियर हो रही है? Sorry, not characteristic, that is annihilating. Yeah. So in this case, the answer is 0 only, because this is characteristic. Once you get the characteristic equation, you can say this is the answer. But in this case, you cannot say. See, मैं बता रहा हूं तुम्हें, ये देख लो लो, तुम कहोगे एग्जांपल दे दो सर, एग्जांपल तो कोई दिक्कत नहीं है। अगर a क्यूब इज इक्वल टू i है और a 2/2 की मैट्रिक्स है, ठीक है, a 2/2 की मैट्रिक्स मैंने दे दिया, लो बताओ a क्यूब इज इक्वल टू i, व्हाट इज द कैरेक्टरिस्टिक, व्हाट इज द रूट, दिस लो जी, रूट a क्यूब i। what is the answer? All these are matrices which satisfy a cube is equal to I, and you cannot decide what are the roots. Am I clear? एक स्टूडेंट ने जवाब दिया yes, and other are enjoying. This is not cinema hall, this is the class, and you have to appear in 2022. देखिए लीनियर अलजेब्रा तो मेरे पास अभी भी इतना बड़ा पड़ा हुआ है, इफ यू थिंक लीनियर अलजेब्रा की तो कोई लिमिट ही नहीं है, मैं आपको बता रहा हूँ। बट दीज आर द क्वेश्चन विच वी हैव डिस्कस अर्लियर आल्सो, एंड दिस इज आल्सो द गुड क्वेश्चंस, ठीक है। बट इवन इन दिस क्वेश्चन इफ यू कैन राइट डाउन, सर a cube is equal to I and A is a 3x3 matrix, then you can say this is a, bhai sab, this is characteristic polynomial. Yes or no? Yes or no? Yes or no?
Yes sir.
Done? क्लियर है ना बात? अच्छा एक बात और है, तुमने डायगोनलाइजेशन पढ़ा हुआ है? डायगोनलाइजेशन, व्हाट इज द मीनिंग ऑफ डायगोनलाइजेशन? विल यू, क्या कह रहा है ये, विल यू प्लीज सेंड सम पीडीएफ और क्वेश्चन, पीडीएफ और समथिंग आपको लगे हमारे लिए अच्छा हो, वही क्वेश्चन मैं करा रहा हूँ, जो अच्छे हैं। देखो देयर इज नो लिमिट ऑफ डूइंग द क्वेश्चंस, है ना, बट आई विल सेंड यू सम क्वेश्चंस within 1-2 days. I will create some more questions and send you. Okay, yes, reducing the matrix to the diagonal form, yes. See, उससे पहले मैं आपको बता दूं, you have the concept of similar matrix. Similar matrix like A is similar to B if there exists some P such that P is non-singular and B can be written as a P inverse AP. Do you know this is a similar matrix concept? And in similar matrix concept, you can tell me, you can just think, sir, if arithmetic multiplicity is equal to geometric multiplicity, wait, अभी बताता हूँ, wait, B is equal to P inverse AP. Just मैं अभी आपसे क्वेश्चन पूछूंगा, जब मेरे से पूछ ले करो डायरेक्ट, आप क्या है ना, जब मैं बीच में पढ़ाता हूँ, जब आप पूछ लेते हो एकदम, मैं कहता हूँ इज देयर एनी प्रॉब्लम, तो कोई बोलता नहीं, तो प्रॉब्लम हो जाएगी। मैं अभी पूछूंगा यस इज देयर एनी प्रॉब्लम, सो यू विल आस्क द क्वेश्चन, ओके। No, wait, arithmetic multiplicity, sorry, algebraic multiplicity is equal to geometric multiplicity, then similar matrix, no. अच्छा, diagonalization, no, wait, that is also not. A is similar to B if there exists some non-singular matrix P such that B is equal to P inverse AP. You know कि similarity is a equivalence relation, we have discussed in our classes also, because A is similar to B, then A is similar to A A is similar to B, then B is similar to A. If A is similar to B, B is similar to C, then A is similar to C. So all these kind of things we have discussed earlier in our previous classes. Done. And you know that similar matrix has same trace, same characteristic value, same characteristic polynomial, same trace, same characteristic value, same characteristic polynomial. Same trace, same characteristic value, same characteristic polynomial. Same determinant. Same determinant. Is it clear? These are the points which we have discussed earlier. Is it clear? Yes. Can I say same eigenvector? Same eigenvector? Yes, Shivani. Yes. Same eigenvector? Answer is no, because we have discussed already P inverse AP. So P inverse AP has eigenvector. If A has eigenvector, eigenvalue lambda. No. See this. Similar matrix has same eigenvector. If algebraic multiplicity equal to geometric multiplicity. Thanu, you are saying if similar matrix has same eigenvector, if algebraic multiplicity is equal to geometric multiplicity. Wait. Okay. A has eigenvalue lambda and eigenvector x. Then what is P inverse AP has eigenvalue lambda, no? So what is the eigenvector? I am saying P inverse x. Why? Because if you multiply P inverse x, if you multiply, then P inverse AP, P inverse x. Finally, you will get P inverse A identity x. So P inverse AX, and AX equal to lambda x. So P inverse lambda x. So finally, lambda times of P inverse x. So is it clear? The eigenvector of this is P inverse x. Yes, eigenvector of that is P inverse x. Okay. So as you are saying, the geometric multiplicity of how can you say if geometric multiplicity is same, then same eigenvector? Geometric multiplicity is equal to, yes, geometric multiplicity is equal to algebraic multiplicity. How can you say, Thanu? Can you speak on a mic? How can you say? Can you explain me? You are saying that geometric multiplicity is same than same eigenvector. How? I am not discussed till now this kind of things. Geometric multiplicity, see, if you have B is equal to P inverse AP. Okay. B is equal to P inverse AP. Then we are saying that P inverse AP of some y must be equal to lambda y, where AX equal to lambda x, because A has eigenvalues lambda, and x is the eigenvector corresponding to lambda. So here we have, if you put like, see, there is a problem. If you have P inverse AP, you put x, same eigenvalues, that will be x, that will be lambda x. How you will say lambda x? In only case when Px equal to x. When Px, first of all, you have to go up to A. There is no way to go A until unless you have identity matrix. then if you say px equal to x, मैंने मान लिया चलो, then ax equal to lambda x, ax equal to x, lambda x. So basically lambda times of p inverse x. px equal to x and p inverse x equal to x. See, px equal to x पहले ले लिया, फिर p inverse x equal to x लेंगे, जब भी तो यहाँ पर lambda x आएगा, थानु. So px भी x है, p inverse x भी x है. So what is the possibility? This kind of matrix only has p and p inverse. If this kind of matrix you will get, then you can say this is only eigenvector x, otherwise not. And this is the question. Sum of geometric matrix is diagonalizable. हाँ, वो होता है diagonalizable question. ये concept नहीं होता है, ठीक है? Yes. So similar matrix has same eigenvalues, same determinant, same trace, same characteristic value, same characteristic polynomial, but not same eigenvector. What about rank? Shivani is saying, sir, similar matrix has same rank. This is right or wrong? Similar matrix has same rank. This is true or false? Similar matrix has same rank. This is true or false? How can you say? How can you say true? How can you say true? Yes. How can you say true? कोई बताएगा? Same eigenvalue, same rank. How can you say same eigenvalue, same rank? Same eigenvalue, then same rank. That's meaning. There is no relation of rank to the eigenvalues. Is there any relation to the rank with the eigenvalues? It means if two matrix has same eigenvalue, then same rank. Yes, very good. See, multiplying, you are multiplying by a non-invertible matrix. Invertible matrix, this is a product of elementary row operation. Elementary row operation does not change the rank, and you are multiplying so many row operations because you have non-singular matrix on the right hand side also. So these and these matrix cannot change the rank of a matrix. So rank of B is equal to rank of A. This is correct. Very good, Manoj. Yes. Am I clear? Yesterday we have discussed, yesterday, day before yesterday, we have discussed this kind of concept. A similar matrix, no, we have, if you multiply, pre-multiply or no, post-multiply by a non-singular matrix, that will not affect the rank of a matrix. Number of non-zero distinct eigenvalue is equal to rank. No. ये कह रहा है भाई नंबर ऑफ नॉन जीरो डिस्टिंक्ट, श्यामा रेड्डी कह रहा है नंबर ऑफ नॉन जीरो distinct eigenvalues is equal to rank of matrix. Is it correct? No. See. In this case, you are saying your example is true. हाँ जी. Am I clear? Am I clear to you? Syama ready? See, this is all eigenvalues. Sorry, this. All eigenvalues are 1 and 0. Rank is 1. Okay, but all eigenvalues 1 0 0 0, but rank is 2. Eigenvalue 1 0 0 0. Eigenvalue 1 0 0 0. Rank 1. Am I clear? Is it interesting? मतलब थोड़ा लगा है चीज चेंज हो रही है थोड़ी सी linear algebra में और भी, but don't be confused. Just this is these kind of problems we are discussing only for you. You boost up. देखो, whatever preparation you have done till now, in the 15 January, whatever preparation you have done, there is no need to study new things. Okay, there is no need to study new things in your life. You have to just focus on whatever you have understood, and we are also just like you have some doubt because you have studied something, you have some doubt, so we are discussing only that one also, only nothing new we will discuss, only small things we can discuss, otherwise no new. This is old concept. Done. Yes.
Sir,
Yes.
I have a myth about idempotent matrix, that every idempotent matrix has zero determinant except identity. Is it true?
Yes, this is true.
Oh, okay.
Every idempotent matrix
Has zero determinant.
Okay, except
Identity. Yeah.
yes. See, this is not myth, this is the correct, but please a little about geometric multiplicity, and yeah, we will discuss, don't worry. I have these questions in my mind.
Okay.
You have idempotent matrix A square is A of any order, like n cross n order. Okay. So by this you can write down this and you can write down this. Acha, have you attended my all the lectures?
Yes, sir. About matrix, linear algebra, I have attended all lectures.
No, I cannot say.
Why, sir?
I can say because all these things we have discussed earlier.
Yeah, sir. Actually, I don't know. I was not able to find these type of question, no, as everywhere else. So that's why I thought that this is myth or not. I don't know.
So here we can write down determinant is a real number, na? So this is determinant is like. So here you can say determinant of 0 is 1. So determinant of a matrix is 0 or 1 only. It means we can say idempotent matrix. Idempotent matrix has determinant 0. Actually होता क्या है ना, मैं आपको बता दूं. I am teaching you like I
नहीं
have.
सर बात ये है कि ना मेरे को ये वाली बात तो पता थी, बट वो आपने लाइक ऐसे नहीं कहा था कि
कुछ और बता रहा हूँ. वेट व्हाट आई एम सेइंग कि you have studied your like 3 year of BSc and the syllabus of IIT JAM is very like little syllabus, but the problem are too much vast, है ना? So we need more and more time to discuss a deep and deeper problem. I can give you the very heavy problems in an easy way, but it will take time, na? So we have limited time, like 6 months, 7 months. I think at least we need 1 year to prepare IIT JAM. अगर आप मेरे से पूरा एक साल कह रहा हूँ, कंप्लीट एक साल रेगुलर मेरे से पढ़ लो IIT JAM का पूरा सिलेबस, then you will have 100% confidence कि definitely I will crack IIT JAM. इतना कॉन्फिडेंस आ जाएगा कि मेरा पक्का IIT JAM में हो जाएगा. अब रैंक क्या आएगी? रैंक तो किसी को नहीं पता रैंक कितनी आएगी, ठीक है? रैंक आपकी रैंक 1 भी आ सकती है, रैंक 10 भी आ सकती है, रैंक 100 भी आ सकती है, पर टॉप 50 तक में आपकी उम्मीद आ सकती है, क्योंकि सिलेबस तो छोटा है बट उसकी प्रॉब्लम्स बहुत बड़ी है. एक एक लाइन को समझाना होता है, बट रेगुलर रहना पड़ता है. रेगुलरिटी, टाइमिंग, ओके, स्टडी प्रॉपरली, ये तीनों चीज मिलने के बाद ही चीजों में कॉन्फिडेंस आता है. मैं ये तो मैं नॉर्मल बात बता रहा हूँ, दिस इज जस्ट ए नॉर्मल बात, बिकॉज हमने 3 साल जो सिलेबस पढ़ा है, ऑल दिस थिंग्स वी हैव डन रेक्टिफिकेशन, नथिंग एल्स. ऐसा होता है तो होता है, बट नाउ वी आर थिंकिंग इन ए राइट वे. वी आर थिंकिंग कि यार ऐसा सर से पूछ लेते हैं ऐसा क्यों होता है, बिकॉज देयर विल बी न्यू क्वेश्चन इन IIT JAM. नो प्रॉब्लम. मैं तो वैसी नॉर्मल सी बात बता रहा हूँ आपको, कोई आई एम नॉट जस्ट ए मोटिवेटिंग और डीमोटिवेटिंग, नथिंग, दिस इज जस्ट नॉर्मल थिंग्स. आइडेम्पोटेंट मैट्रिक्स हैज इस problem say if this is a matrix, if you are saying this is idempotent, yes, this is the definition of idempotent. It means idempotent matrix has zero determinant of 1. Okay. So A square is equal to A. This is called idempotent matrix. So this has either zero determinant or this has determinant of 1. Am I clear? 0 or 1. If determinant is 1, it means determinant of A is non-zero. It implies A inverse exists. If it means A square is A as well as this, it means A square is equal to A, and you are multiplying pre-multiplying A inverse because A inverse exists. So it means A is equal to Y. It means the idempotent matrix with the determinant 1 is only identity. The idempotent matrix with the determinant 1 is only identity. And we cannot say anything about we have infinitely many idempotent matrix, which has determinant 0. So it means a matrix which is idempotent and having determinant 1 is only identity matrix. Now it is clear, Chetan?
Yes, sir. Now I'm clear. Actually, that is what I want to ask. No, how that's
this
I
thing we
got
have
the
discussed
answer.
already in our classes. See, मैंने अपनी क्लासेस में बहुत प्रॉब्लम्स क्लियर कराई हैं. सी, अब वो क्लियर और ज्यादा करना वो आपके हाथों में भी है. इफ यू डू मोर एंड मोर प्रैक्टिस, इफ यू थिंक मोर एंड मोर प्रॉब्लम, इफ यू गूगलिंग मोर एंड मोर कंसेप्ट ऑन गूगल, लाइक ऐसा क्यों होता है, ऐसा क्यों होता है, इफ यू थिंक मोर एंड मोर, इफ यू गिव मोर एंड मोर टाइम टू द सब्जेक्ट, यू विल हैव ए बेटर अंडरस्टैंडिंग, है ना. इफ यू, बिकॉज एक बार पढ़ने से तो कभी चीज समझ में आती नहीं. वंस यू डू, then you are not a like super man कि you will understand all these things. मैं भी ऐसे ही था आपकी तरह. मैं कोई कहीं का बॉन्ड कोई हूँ. I am not like perfect. Even I am learning. I am also in the learning phase because every teacher is a student. Okay, so I am also in the learning phase. So सभी का यही हाल होता है. एग्जाम में जाने से पहले when you go to the exam, before going to exam, you will also think, you will also have a problem कि सर मुझे कुछ नहीं आता, मुझे कुछ नहीं आता. ऐसा हो सकता है कि सर मुझे कुछ भी नहीं आता है और मुझे तो कुछ याद ही नहीं है, मुझे तो कुछ याद ही नहीं है ना. सबके साथ होता है, मेरे साथ हुआ. तो ये प्रॉब्लम सबके साथ है. इससे डरना नहीं है एग्जाम में, मैं आपको फिर बता दूं. ठीक है. दिस इज आल्सो ए पॉजिटिव साइन. यू डोंट नो एनीथिंग बिकॉज यू हैव डन ए लॉट ऑफ, सो यू विल थिंक कि यू हैव नॉट done anything, है ना. मुझे वो याद नहीं है. When you appear in the exam, you write up, you will write down some question in the exam, then you automatically दिमाग से सारी बात निकलते आती रहेंगी, हाथों से लिखते रहोगे, सॉल्व करते रहोगे. ठीक है.
यस सर. ऐसी थिंकिंग तो वैसे नहीं आती है सर. थोड़ा सा ना ऐसी थिंकिंग आती नहीं है. एक्चुअली गीता पढ़ ली थी ना, तो उसमें वही अर्जुन वाली बात ना, वो मना करता रहता, नहीं लड़ूंगा कुछ, मैं नहीं लड़ूंगा. तो दैट्स लाइक थोड़ा बहुत रिलेट हो जाता है इससे. यहाँ ऐसा नहीं सोचना चाहिए.
See, I just want to give you like 5 minutes more about this. Don't be think about the selection.
Yes.
Final selection, because final selection is not in your hand. कितनी भी हार्ड वर्क कर लो, फाइनल सिलेक्शन आपके हाथ में नहीं है. आप अपने हार्ड वर्किंग से you can near about your final selection, but not at final selection. जो फाइनल सिलेक्शन है, दिस इज इन द हैंड ऑफ गॉड. ठीक है. बेसिकली हमारे पास है ना, जो गॉड, लाइक देयर इज ए पावर. ओके, देयर इज ए पावर like in the space you can think about. Okay, there is a power and we have a thread, मतलब that power has a thread. ओके, एक तुम्हें कठपुतली देखिए, कठपुतली. यस, कठपुतली.
हाँ सर, वो उंगली से नचाते हैं उसको.
नचाते हैं. ओके, क्या कहते हैं कठपुतली इंग्लिश में?
पता नहीं सर.
पपेट है ना, पपेट कहते हैं. पपेट्स ही कहते हैं आई थिंक कठपुतली को. सो यू हैव ए पपेट, सो वी आर ए पपेट एंड गॉड हैज ए थ्रेड. ओके, सो वी आर पपेट. गॉड हमें जैसा करने को कह रहा है हम करते जा रहे हैं. हम सोचते हैं We are thinking I am Ashish Garg, I am IT and I am teaching here, I am earning this, I am doing this, I am doing this. Actually, I am not doing anything. Some energy is forced to me to doing this. And I am thinking I am doing this, I am going to IIT, I am teaching here, I am doing here. You think I am solving problem of IIT JAM, I am learning a lot from Eduncle, I am doing this. No, nothing. All these are पहले से planning है, planned. But let us consider this puppet has no energy. Puppet की मर्जी नहीं है कुछ करने की, so वो thread भी घूमेगी नहीं. ओके, तो वो thread घुमाएंगे तो वो जैसे मान लिया कोई आदमी, मान लिया कि जस्ट पपेट है, मान लिया वो उठ ही नहीं रही, मान लो लेटी हुई है जमीन पर. ओके, तो उसे कहते हैं ना घिसेट के ले जाते हैं, तो कुछ कर ही नहीं रही, वो कुछ नहीं है. घसीट के मतलब जिंदगी ऐसी खराब होके चली जाएगी एंड फाइनली यू विल लाइक एंड अप हो जाएगा. बट आपके पास है, आप उसका यूज करोगे, इसका मतलब ये नहीं है पढ़ाई नहीं करनी, पढ़ाई करनी है. ठीक है, पढ़ाई अपने को इंटेलेक्चुअल बनाने के लिए होती है, जॉब पाने के लिए नहीं होती. बेसिकली अवर थॉट इज कि if we study more, if we go IIT, we will get good job. No, this is not the right approach. मैं भी यही सोचता था. But the right approach is, if you study more, you will be more intellectual. And if you will be more intellectual and you can give something more intellectual thing to this universe, okay, this society. We are here not to show our intelligence. We are here to develop our society. हम अपनी सोसाइटी को डेवलप करने के लिए हम यहाँ पर इस धरती पर हमने जन्म लिया है, डेवलप करने के लिए. क्यों? क्योंकि अगर हम डेवलप ही नहीं करेंगे तो ये सोसाइटी क्या होगी, जो भगवान की बनाई हुई ये जो यूनिवर्स है ना, ये खत्म हो जाएगा. समझ रहे हो? सो डोंट बी थिंक अबाउट सिलेक्शन, जस्ट थिंक कि आई हैव स्टडीड these things and I will try to do my best and I will study, I will complete my syllabus as soon as possible, whatever sir has taught and whatever book, whatever syllabus we have, and I will do more and more problem from here. Okay, and think about यार मेरा सिलेक्शन नहीं होगा तो क्या होगा, इसका तो हो जाएगा, ये तो इंटेलिजेंट है, ये इसका. Don't we do any kind of comparison, because destiny of every person is different. Okay, so think about positive things. Yes, whatever will be happen, that will be good sign for me. Okay, सबके लिए अच्छा होता है, किसी के लिए बुरा नहीं होता, सबके लिए अच्छा होता है. Do hard work. Okay, be positive. नेगेटिविटी निकाल दो दिमाग से, जितना कर लिया उसे कर लो. ठीक है ना? और मैं तुम्हें अभी आगे एंड में गाइड करूंगा चीजों के बारे में. डन? मैं अपने टॉपिक से थोड़ा हट गया हूं, बट सॉरी, बट दिस इज आल्सो मतलब बहुत ज्यादा जरूरी था ये बात बोलनी, क्योंकि कंफ्यूज नहीं होना, क्योंकि ऑल ऑफ यू आर गुड स्टूडेंट. ओके, मैं आपको बता दूं, रियलिटी बता देता हूं कि मैं आपसे मिला नहीं हूं, बट मैंने तो खुद when I pass IIT, like when I enter in IIT JAM exam, at a time I can say I was not good student, because क्योंकि मेरे पास कोई टीचर ही नहीं था, मुझे बताएगा कौन कि भाई तुझे कुछ आता है नहीं आता है. मैंने खूब मेहनत करी है, बट मुझे पता ही नहीं था मैं गुड हूँ. मैं तो अपने आप को ऐसे ही मानता था. क्यों मानता था भाई? कोई कंपैरिजन ही नहीं है. ठीक है, मैं तो कहता ठीक है, बस नॉर्मल है. बट आई हैव डन ए लॉट ऑफ problems in linear algebra and all these things in my BSc. I have completed my Gallian book in my BSc. All these things. Even I did not went to the college in a single day. Okay, in 3 years. ठीक है ना भाई? उस समय मेरा 110 रैंक था, 110 रैंक है ना, विदाउट एनी कोचिंग, नथिंग. इंटरनेट तो था ही नहीं. 2009 आई वॉज नॉट, मुझे ना लाइक इंटरनेट तो ये अब चला रहे हैं ना, एंड्रॉइड तो था ही नहीं, एंड्रॉइड आल्सो नॉट देयर. इवन आई डोंट हैव सेल फोन आल्सो. सो इंटरनेट में कुछ नहीं, जो बुक से ही पढ़ना था, प्रॉब्लम का सोल्यूशन कोई बताने वाला नहीं था. तो पर मैंने भी आपकी तरह ही जो पॉजिटिविटी सोचा, पॉजिटिविटी से आगे बढ़ गए. ठीक है, और आप लोग भी, मैं ये कह रहा हूं कि यू विल आल्सो ऑल ऑफ यू, आप कंपैरिजन करते होगे कि हम सर की तरह बन जाएं. बहुत सारे ऐसे आइडियल सोचते हैं, बट मैं आपको कह रहा हूं आप मेरे से बहुत बहुत आगे जाओगे, ठीक है, बहुत बहुत आगे जाओगे, बिकॉज वट एवर यू आर लर्निंग नाउ, मतलब हो सकता है कि मुझे भी इतना ना आता हो उस समय। क्यों? क्योंकि उस समय तो कोई इंटरनेट का जमाना भी नहीं था ना, न्यू प्रॉब्लम्स, वेरी न्यू प्रॉब्लम्स, वेरी डिफरेंट प्रॉब्लम्स, कोई बताने वाला भी नहीं था। पर तुम्हें तो कोई बताने वाला है, इंटरनेट है, यूट्यूब है, मैं हूं, और सब कुछ है, मटेरियल्स है हमारा, ठीक है। सो यू हैव टू थिंक इन ए पॉजिटिव डायरेक्शन, वी आर ऑन द राइट वे। ओके, कितने मार्क्स थे मेरे? मेरे मार्क्स मार्क्स तो मुझे एग्जैक्टली याद नहीं है अब, 110 रैंक थी। मुझे ऐसा याद है कि अराउंड मेरे ऐसी मार्क्स थे 45 अप्रोक्सीमेट, 45 मार्क्स अराउंड थे मेरे, आउट ऑफ 100, आउट नहीं, आउट ऑफ 300 था, 45%, सॉरी, पेपर था 300 का, 45% अप्रोक्सीमेट, है ना, ये था। उस समय कट ऑफ थोड़ी कम थी, है ना, बिकॉज 45% भी नहीं आते थे,
यस सर,
बुक
समझ सकते हैं।
बुक ही नहीं थी, कौन बताएगा, कौन पढ़ाएगा, ठीक है।
अभी भी हम लोग देने जाते हैं, मतलब नॉर्मली अगर थोड़ा कठिन सा हो जाता है ना टेस्ट सीरीज में भी, तो 30-35 आ पाते हैं। आप तो उस टाइम पे भी 45 लिया है, तो इस
45%,
बात, वही बात है सर, हम इस बात पे रिस्पेक्ट है, मतलब कि हाँ 45 आप उस टाइम पे भी लिया है।
ऑल दिस थिंग्स आर इमैटेरियल। देखो, कोई किसी की रेस्पेक्ट करे ना करे, कुछ भी करे, दिस ऑल दिस थिंग्स आर इमैटेरियल। द मेन थिंग इज कि यू हैव टू अंडरस्टैंड कंसेप्ट ओनली। आप मेरी रेस्पेक्ट करो मत करो, अच्छा मानो बुरा मानो, मेरा एम ये है कि आप मेरे से कुछ गेन करके जाओ, ठीक है, ठीक है।
सर सीएसआईआर नेट को लेकर के आपका मतलब क्या कहना है? जैसे आपने बताया कि 1 साल कम से कम चाहिए जैम के लिए, उस प्रकार आप सीएसआई नेट के लिए लगभग आपके हिसाब से कितना समय देना चाहिए? अगर
ये सर यार काम चालू
मतलब
है एडंकल पे, मोस्ट प्रॉब्ली दिस ईयर वी विल डिस्कस, डोंट वरी, वी विल डिस्कस। अभी सीएसआर के बारे में चक्करबाजी मत डालो, जस्ट थिंक अबाउट दिस वन। और सारी प्रॉब्लम्स करानी है अभी, यस। चलो ठीक है, लेक्चर हुआ, थोड़ा सा आपको पॉजिटिविटी लगी होगी, आई होप। आइडेम्पोटेंट मैट्रिक्स हो गई। अभी आपने मेरे से क्वेश्चन क्या क्या पूछा है? यू हैव asked me question about nilpotent matrix. Yes, you can tell me what are the questions, you can write down here. One is asking arithmetic algebraic multiplicity and geometric multiplicity. Some more questions you are asking?
सर यस, अगर लीनियर ट्रांसफॉर्मेशन को एक मैट्रिक्स में दे रखा है तो उसके बारे में एक चीज पूछनी है।
मैट्रिक्स, ओके, वन
उसको
मोर।
मैट्रिक्स दे रखा है, उसमें बोल रखा है कि
मैं
इट
समझ
डज
गया
नॉट।
क्या कह रही है, मैं समझ गया सब कुछ, यस। और बताओ, एनी अदर प्रॉब्लम, एनीबॉडी वांट टू आस्क? Nilpotent if only all eigenvalue 0, am I right? Nilpotent if all eigenvalue 0, right? Any other problem you are asking? Okay, okay. Similar matrix implies rank same, no. Okay, non distinct eigenvalue equal to rank. Multiply inverted matrix, yes. Diagonalizable का concept बता दीजिए, diagonalizable. Okay, yes. Dimension of matrix, कभी भी डायमेंशन किसी मैट्रिक्स की होती ही नहीं है, ठीक है। This is a wrong concept, but we will discuss this concept also. So you have these problems in the diagonalizations, till diagonalizations. See, number one problem, what is nilpotent matrix? अच्छा, एक बात मैं बता देता हूँ, पहले मैं क्वेश्चन करा देता हूँ। लेट A is n cross n real matrix, real matrices, okay, symmetric with eigenvalue 0, 1 only, मतलब उसकी आइगन वैल्यू 0 और 1 है। ए मैट्रिक्स है, एक ए इज अ मैट्रिक्स which has eigenvalue 0 and 1 only. Yes, 0 and 1 only. A symmetric matrix with geometric multiplicity of eigenvalue 1 is m, then can you find characteristic polynomial? Can you find characteristic polynomial? Yes. See, lambda minus 0 की power, what is power? And lambda minus 1 की power what? We don't know. Can you write down? I am asking characteristic polynomial. Anu, I am asking characteristic polynomial. Characteristic polynomial x into x minus 1 is not. That is x into x minus 1. X की power something, x minus 1 की power something. The power sum of the power is n. Yes or no? N cross n matrix. See, this is n cross n matrix. No, I am not asking 2 cross 2. I am asking n cross n generalized case. I am asking. Just take 2 minutes. This is the question in IIT JAM 2022. Okay. This is the question in IIT JAM. This is the question in IIT JAM. Just think and tell me what is the answer.
सर लेमडा की पावर n माइनस m हो जाएगी और लेमडा माइनस 1 की पावर m.
No? How can you say?
Sir, geometric multiplicity of eigenvalue 1 is given m.
Okay. So how to find out the algebraic multiplicity? Algebraic, there is no relation of geometric and algebraic. If geometric is m, then algebraic is greater than or equal to m.
Yes, sir.
Yes.
But sir, less than or equal to n also, no?
Yes. How to find out? There are so many polynomials. Actually, we don't know about the polynomials. We don't know about the matrix. If matrix is known, then you can write down the answer. If matrix is not known, you cannot write down the answer. Yes or no?
Yes, sir.
One has degree n minus m and other has degree m. Why? X की power n minus 1, x minus 1 की power 1. X minus 1 की power 1, why? X minus 1 की power 1, why? अरे algebraic multiplicity is always greater than geometric multiplicity. So answer is greater than m. Why you are writing 1, Thanu? Why are you writing 1? X minus 1 की power r1 और x minus 0 की power r2. r1 is greater than m and r2 is greater than equal to. मुझे नहीं पता r2 what is r2 because geometric multiplicity we don't know. Yes or no? Because r2 is less than n. I don't know about that. But basically this is the power. Total sum is r1 plus r2 is n. Yes or no? Yes or no? Is it clear to till now? Is it clear? But I want to tell you, you have मतलब तुमने एक चीज नहीं देखी इस प्रॉब्लम में. इस प्रॉब्लम में सिमेट्रिक मैट्रिक्स गिवन है and the symmetric matrix is always diagonalizable. We have discussed earlier, but why? How can you forget the thing? Symmetric matrices are always diagonalizable and orthogonally diagonalizable. Symmetric matrix is diagonalizable और उसकी जो बेसिस बनती है ना, आइगन वेक्टर की बेसिस बनती है, वो ऑर्थो नॉर्मल बेसिस बनती है ना. I think you might have studied this kind of things in our classes. Symmetric matrix is diagonalizable. Yes or no? Yes or no? याद है, किसी को पता है कि symmetric matrix is always diagonalizable? Yes. If symmetric matrix is diagonalizable, you have 0 is eigenvalue, 1 is eigenvalue, algebraic multiplicity is greater than equal to that is algebraic multiplicity is greater than equal to m, and what is the algebraic multiplicity of this? Algebraic multiplicity is like if this is greater than m, what is the algebraic multiplicity of this? Basically, if geometric multiplicity of this is m, then geometric multiplicity of 0 is n minus m. Why? Because we know that algebraic multiplicity is equal to sum of algebraic multiplicity, जितनी भी algebraic multiplicity होंगी वो होंगी n, पता है ना सबको. But sum of geometric multiplicity is less than equal to n. Yes or no? Sum of geometric multiplicity is equal to n if and only if matrix is diagonalizable. अगर मैट्रिक्स डायगोनलाइजेबल है तो सम ऑफ ज्योमेट्रिक मल्टीप्लिसिटी इज इक्वल टू n. Exactly n. This is the theory we have discussed. There is no rule that algebraic multiplicity of particular eigenvalue equal to geometric multiplicity. Algebraic multiplicity of particular eigenvalue geometric multiplicity, there is no guarantee. समझ रहे हो मेरी बात? Algebraic multiplicity of particular eigenvalue equal to geometric multiplicity, दूसरे की algebraic multiplicity equal to geometric multiplicity, तीसरे की algebraic multiplicity equal to geometric multiplicity. No. This is not the concept of diagonalizable. The concept of diagonalizable is a set of all possible eigenvalues. The algebraic multiplicity is always equal to n, but geometric multiplicity is not equal to n, less than equal to n. If equal to n, sum of all geometric multiplicity, then matrix is diagonalizable. Here, because matrix is diagonalizable, so geometric multiplicity is m, so total is n minus m. It means algebraic multiplicity is greater than equal to n minus m. See, algebraic here greater than m and greater than equal to n minus m. So if you take greater than m, n minus m, तो कम से कम n minus m plus 1 लेनी पड़ेगी, यहाँ पर m plus 1 लेनी पड़ेगी. So basically you will have n plus 2 is the geometric multiplicity. Algebraic multiplicity का सम क्या आ जाएगा? What is the answer? You will have n plus 2, but this must be 10. So can I say here कि here also algebraic multiplicity must have to m and n in this case only. Am I clear? So in this case, I think it is clear what is the meaning of diagonalizable, what is the meaning of diagonalizability, and algebraic multiplicity and geometric multiplicity is also clear. I will discuss some problems also for algebraic and geometric multiplicity. Done. So algebraic multiplicity is greater than equal to n minus 1. Algebraic multiplicity is greater than equal to m. And sum of algebraic multiplicity is always equal to n. That is possible if and only if algebraic multiplicity is equal to n minus m, and geometric multiplicity, algebraic multiplicity of 0 is n minus 1 m, and algebraic multiplicity of 1 is equal to m. So you can write down the characteristic polynomial in this case is lambda minus 0 की power n minus m and lambda minus 1 की power n. Is it clear? Can I say by the help of this matrix a की power k is equal to a की power k plus 1 for all k belongs to 1. So this is the right option. This is the right option. ठीक है? Second option is right. Second option is right or not? Second option is right or not? A की power k is equal to a की power k plus 1 for all k belongs to m. Why? See, what is the meaning of this problem? The meaning of this problem is a की power k is equal to a की power k plus 1 for all k belongs to m. What you are thinking? You are thinking in this way: a की power k का determinant equal to a की power k plus 1 determinant. I know what you will think. I know. नहीं, हाउ कैन यू से डिटर्मिनेंट ऑफ a की पावर k is 0 या फिर डिटर्मिनेंट ऑफ a is equal to 1. सो ठीक है, दिस इज ओके. a की पावर k 0 मतलब डिटर्मिनेंट इज 1. डिटर्मिनेंट a या तो 0 होगा या फिर 1 होगा. ये कह रहा है. यस, दिस इज राइट. डिटर्मिनेंट इज 0 ऑलवेज. Yes or no? Determinant is 0 always. Yes or no? So this is possibility. This is correct. You are saying this is correct. Yes or no? Because geometric multiplicity of 1 is 1. How can you write down? This is the meaning of geometric multiplicity. How can you write down? This is for all k. No. So by this you cannot say. You are saying sir geometric multiplicity लग तो ठीक रहा है पर ये ऑप्शन गलत है. This option is wrong. Why this option is wrong? For all k belongs to 1. तो मतलब क्या है? a equal to a square. A square is equal to a cube. A cube is equal to a4. Am I clear? The meaning of this problem is yes or no? Am I clear? Because n is k is equal to 1 डाल लो, 2 डाल लो, 3 डाल लो, 4 डाल लो, सब डाल लो. So can I say कि a is equal to a square is equal to a cube. तो a is equal to a square is equal to a cube और a cube is equal to a4 और a4 is equal to a5 और a5 is equal to a6, a6 is equal to a7, a7 equal to a8 and as yes or no? A is equal to a की power n. Yes or no? So I can say कि a equal to a की power n or I can say the thing. Just think. So student, sorry. So a is equal to a की power n. A की power n, it means a की power n equal to a, and you can say a की power n minus a is equal to 0. So we can say lambda की power minus lambda is equal to 0. This is a characteristic polynomial. Yes or no? By this way we can say कि मैट्रिक्स में आप कह रहे हैं कि दिस इज कैरेक्टरिस्टिक पॉलीनॉमियल. Is it clear? Is it clear? So this is not possible because characteristic polynomial is, what is the characteristic polynomial? Characteristic polynomial of this matrix is lambda minus 0 की power n minus m and lambda minus 1 की power m. But this is lambda की power 1 and lambda minus 1 की lambda की power n minus 1. So this is not the right way. Is it? क्या मेरी बात समझ में आ गई सभी को? कैसा लगा क्वेश्चन? द क्वेश्चन इज वेरी गुड. इस तरह का क्वेश्चन आईआईटी में आ सकता है, बट दिस इज रेयर. रेयर मीन्स लाइक IISc Bangalore has created this kind of questions. IISc Bangalore has created this kind of questions. Not every IITs, not every time you will get this kind of question. This is the most difficult questions. This kind of questions we have. Very good. So next question in this problem. ऐसा नहीं है क्वेश्चन आईआईटी में आएगा, ऐसा जरूरी नहीं है. Don't be worried about. I am just giving you some technique, some time. Okay, this kind of technique. Next question is rank of A. Find rank of A. Can you tell me what is the rank of A? What is the rank of A? Rank of A in this problem? Yes. Rank of A is M. Simple, because the simple thing is the system is hang. Just 1 minute. Yes. A geometric multiplicity of A equal to n minus m. What is geometric multiplicity of A? Number of Li eigenvector is equal to n minus m. So that is hota n minus r, the rank of m. Okay, where r is the rank of m. Yes or no? So r is equal to m. It means this is the problem. This is clear, I think. So this point is clear to all of you. Done. So can I say concept of diagonalizable is done? Concept of diagonalization is done. Concept of diagonalization means the sum of all the geometric multiplicity, the sum of all the geometric multiplicity of all the eigenvalues equal to n, then matrix is diagonalizable. And matrix is diagonalizable, then if a matrix is diagonalizable, then matrix A is diagonalizable, then you must have a matrix A, P, which is non-singular such that A is similar to D. Matlab a matrix is diagonalizable means matrix is similar to a diagonal matrix. Okay, you know this concept, है ना? Matrix is diagonalizable. So matrix A is diagonalizable if matrix A is diagonalizable if sum of geometric multiplicity is equal to n. Okay, and A is similar to diagonal matrix. What is P? P is a matrix by forming all linearly independent eigenvectors. See, you are saying the geometric multiplicity is n, it means you have n linearly independent eigenvector. Yes or no? You have n linearly independent eigenvector like alpha 1, alpha 2, alpha 3 up to alpha n. Put in a column wise all these things. Put in a column wise all these things. Then you can say, okay, this is the P matrix. If you are saying this is a diagonalizable. Am I clear? Yes or no? Diagonalizable concept is this is one. And you know that in diagonalization, if D is equal to P inverse AP, then D ki power R is P inverse A ki power RP. Do you know this thing? This is also one of the most important concept. There's so many questions has been asked in this topic. Yes, this is clear now. Yes, why? Because you will multiply. Because as you write down D square, that is P inverse AP, then P inverse AP, then P inverse cancel, so P inverse A square P. Then further you can write down like this. Okay, one more question. It means if A is diagonalizable, then A square is also diagonalizable. Yes or no? A is also diagonalizable. Can I say like this? If A is diagonalizable, then A square is also diagonalizable. Yes or no? Because see, A square can be written as a D square, and D is a diagonal matrix, then D square is also diagonal matrix. So it means this is a diagonalization concept. Done. Okay. One concept is in a similar matrix. जब हम कहते हैं कि A is similar to B, A is similar to B, then there exists some P B is equal to P inverse A. Yes or no? My question is that is P unique? क्या P कोई यूनिक मैट्रिक्स होती है? In case of diagonalizations, the matrix is unique. Diagonalization नहीं कह रहा हूं. In case of similar matrix, is it unique? Yes. Answer is no. This is not unique matrix. You can have infinitely many matrices. You can have infinitely many matrices. Not. This is not unique. बताओ क्यों? P matrix is not unique. See, I am giving one very simple example. Yes. One question is 1, 1, 1, 1, 1, omega, omega square, omega 4. Have you done this problem before? कोई बात नहीं भी करिए तो मैं देखा बता देता हूँ. 1, 0, 0, 0, minus 1, 0, 0, 0, 0. 1, 1, 1, 1, 1, 1 by omega square, 1 by omega square, 1 by omega 4. See, this problem is there. Question is that this is a B matrix. Find eigenvalues of B. Pehla question. First question, this is the eigenvalue of B. Can you find out what is the eigenvalue of B? There is two technique. One is short trick. One is long trick. The long trick I am just explaining. First of all, the long trick is you have a matrix, multiply all the matrix, find out the matrix, find out the characteristic polynomial, and find out the characteristic polynomial, find out the which one? Eigenvalue. But this is very lengthy. Do you have any other technique? Are you thinking in some other way? Can you find out this answer? Simple question, very simple. Yes. आप बता सकते हो. Wrong answer. You are saying 1 minus 1 0. This is wrong answer. See, first of all, whenever you will see three matrix, so there is a concept of either diagonalization or either similar matrix. Yes or no? Basically, concept of similar matrix. You know, similar matrix has same trace, same eigenvalue, same determinant, same rank, something same. Yes or no? So as you have seen, Pratiksha, this is P inverse, this P, and you are saying this one. Yes or no? You are saying like this, na? This P inverse P, this is A. But have you checked this or this are P inverse? Have you checked if this is P inverse, this is P, so P inverse P must be identity? Yes or no? Have you checked, or directly without checking you have write down 1 1 1 1 1 omega square omega 4 1 1 1 1 1 1 by omega square 1 by omega square 1 by omega 4. Just multiply. What is the answer? What is the answer? Please write down. Can you tell me what is the answer? So if you multiply, this is 3. If you multiply this, तो क्या आएगा 1 plus 1 by omega plus 1 by omega square. क्या आंसर आएगा जी? What is the answer? What is this? Can I write down 0? I can tell you this is the matrix. You can tell me this is the matrix. So what is this? Is these two matrices are inverse of each other? Is these are the matrix inverse of each other? क्या आपको लग रहा है ये inverse है? Inverse means identity. This is not identity. Yes or no? Student, my dear student. क्या बातें समझ में आ रही हैं? These are not inverse. So I can say one thing. This is 3i. इस 3 को उठा के इधर फेंक देते हैं. इस 3 को उठा के लेफ्ट हैंड साइड में आप शिफ्ट कर देते हैं. So what you will get if I do 1 by root 3 of 1 1 1 1 1. समझना मेरी बात. That is omega. This is the problem. And 1 is, this is also 1 by root 3. 1 1 1 1 1 1 by omega 1 by. Now this is the inverse of P. P inverse then P. Yes or no? Because this multiplies identity. Am I clear? Am I clear now? The problem, how the problem is formed? Yes or no? Is it clear, all of you student? Yes. Is it clear? All of you. So basically problem was, whatever problem was, you have problem this one. So what I am saying ki now this is. So basically these are inverse. So basically if I multiply by 3 here also, can I say now ki B can be written as this one? See, student, please just understand my point. This is P inverse. This is P. दोनों का इनवर्स है आपस में ये. Yes or no? ये दोनों के इनवर्स है तो उसमें 1 by root 3 से मल्टीप्लाई करना पड़ेगा. दोनों 1 by root 3. So 3 you are multiplying here. So basically you will get B matrix only. Now you can say this form is this one. It means this matrix has eigenvalue 3 minus 3 0. So it means this is the right option. Am I correct or not? Yes. Am I correct? So whatever you were thinking, the similar matrix concept, the concept is similar matrix, but you have to check P inverse AP, P and P inverse are the matrix which are inverse or not. These are not the inverse. We have created the inverse. We have made this as an invertible matrix. Okay, invertible matrix is already there, but we have created the inverse of each other, P inverse AP. Then we have multiplied something and we have found the answer. Is this clear to all of you? समझ गए? अब यहां से कॉन्सेप्ट और समझते हैं जरा. Yes. अच्छा, if this is answer, this is the inverse, can I say this is also inverse of each other? Just think my point. If these two matrices, these two matrices are inverse, P inverse P. If multiply 2 here, divide by 2, these two are also inverse. If you including this, these are also inverse. Yes or no? तो मतलब ये है कि P इनवर्स AP बना रहे थे, अगर यहाँ पे 2/√3 भी कर लेता मैं, 1/2√3 ले लेता, तो यहाँ पर तो मैट्रिक्स तो वही बन रही है. इट मीन्स P इनवर्स, मेरी बात समझिए, हाँ, आइगन वैल्यू स्टिल सेम. यस, it means what I am trying to say. See, if B is equal to P inverse AP, then B is equal to 2P inverse A 2P. Yes or no? Because 2P inverse, what is 2P inverse? 2 inverse P inverse A inverse 2P. 2 and 2 inverse cancel, P inverse AP. Yes or no? It means, student, you can have P not unique. You can have infinitely many P. Multiply P by any real number. Multiply P by any real number. All these matrices are, you can create so many matrices. Yes or no? मेरी बात समझ में आ रही है, नहीं आ रही है? Yes or no? So you can have infinitely many matrices. So P is not unique. समझ गए? बहुत क्वेश्चंस हैं. Questions are unlimited in my point of view. There are so many questions. इतने questions हैं. एक साल कम है लीनियर अलजेब्रा के लिए. लीनियर अलजेब्रा 1 ईयर में मेरी कंप्लीट नहीं होगी. तुम्हें पता भी होगा, लग भी रहा होगा कि 1 ईयर ये कराया नहीं, तो सर आपने क्यों नहीं कराया? भाई स्टेप बाय स्टेप चलेंगे ना. बट डोंट बी वरीड अबाउट whatever I have taught, that is sufficient in my point of view. Whatever I will taught till 10 or 8, 9, 10 February, these are the sufficient lectures for cracking any exams like IIT JAM, ISI, CMI. But even IIT JAM, you can easily crack with good rank if you do all the concept which I have discussed in your classes. Done? चलिए ठीक है भाई. इंटरेस्ट आ रहा है, नहीं आ रहा इंटरेस्ट? These are interesting problems. So basically मैंने क्वेश्चन पूछा था आपको, diagonalizations is the diagonalization is also clear. So in diagonalization, if somebody asks the matrix P is unique, the D is equal to P inverse AP, the P is unique. Is P unique? Is P unique? तो आपको होगा. अच्छा, वैसे भी हम बात करते हैं, जो सोच के बताना, तो सोच के थोड़ा सा थिंक अबाउट. हाउ टू क्रिएट P? ऐसे लेते हैं. हाउ टू क्रिएट P इन डायगोनलाइजेशन. In diagonalization, how to create P? Take all the eigenvectors linear independent. अच्छा बताइए, eigenvector ले लिया, किसी ने एक eigenvector alpha 1 की जगह 2 alpha 1 निकाल दिया. Just think my point. Actually, alpha 1 is a linearly independent eigenvector, but this linear independent has infinitely many eigenvectors corresponding to alpha 2, 2, 3 alpha, 4 alpha, k alpha. If somebody is writing 1, 1, 1, somebody is writing 2, 2, 2, somebody is writing 3, 3, 3, somebody is writing 4, 4, 4. Only single vector change, even the matrix is P. Yes or no? Am I clear? मैं diagonalization के लिए बता रहा हूँ. In diagonalization, let us consider you have a matrix. Let us consider you have this eigenvector 1, 0 and 1, 1. Yes or no? This is the vector alpha 1. This is the alpha 2. मान लीजिए 2 by 2 matrix we have. Okay. Then if somebody is writing 1, 0, then somebody can write down alpha 1 a linearly independent eigenvector. This is also. So this is also P. Yes or no? If somebody say, nahi, I will write down alpha 2 here, alpha 1 here. This is also. So you can change the row also, column also. All these things you can change. Yes or no? And here you can say, sir, I will write down 2, 2 and 5, 5. Yes, and this is also P. So basically, when you create P, you put column-wise linear independent eigenvectors, and linear independent eigenvectors are having infinitely many possibilities, because if vector alpha 1 is linear independent to alpha 2, then k alpha 1 is linear independent to some other P like k2 alpha 2. Am I clear? It means basically this P also in diagonal matrix also we have infinitely many possibility of P, and P is not unique. Am I clear? एक क्वेश्चन मैंने कराया जिससे हमारे बहुत सारे कॉन्सेप्ट क्लियर हो चुके हैं, है ना? There are so many concepts are clear by the help of this question. अच्छा, last year I think there is one problem of linear algebra. कुछ प्रॉब्लम थी 2020. This is the problem. Yes or no? This kind of problem was there, I think. We have discussed this question, है ना? Oh, this question we have discussed. Sorry. So elementary row transformations change the rank. Cannot change the rank, but can change the determinant. Block matrix, yeah, we will discuss. Don't worry. We have lot of problems here. First of all, we have lot of problems here.
Sir, JAM 2021 last question number 60.
अभी करेंगे जरा पहले ये टॉपिक कंप्लीट कर लेते हैं ना, ये टॉपिक से रिलेटेड करा रहा हूँ सारा मैं, ठीक है? डन? मुझे भेज देना, मुझे ना व्हाट्सएप पे भेज दो, डेटा मुझे भेज दो. वी विल डिस्कस ऑल दिस प्रॉब्लम टुमारो ना. पहले मुझे जरा ये टॉपिक कंप्लीट कराने दो, इस टॉपिक का कोरिलेशन है हमारी प्रॉब्लम के साथ. जस्ट 1 minute. Block matrix also we will discuss. So diagonalizable is clear, diagonalization is clear. Yes. Algebraic multiplicity and geometric multiplicity is clear. Geometric multiplicity is the number of linearly independent eigenvectors. बताइए फटाफट. Geometric multiplicity is clear, yes or no? Is there any problem in the geometric multiplicity and eigenvalue, eigenvectors? Yes. Geometric multiplicity is clear, algebraic multiplicity is clear, diagonalization is clear. Nilpotent matrix. Nilpotent matrix. Nilpotent matrix is a matrix. Nilpotent matrix. A is n cross n matrix. Okay, A is n cross n matrix such that A is non-zero. Though zero matrix is always nilpotent, but we are taking non-zero matrix. Na? A square is also non-zero. A की power r is also non-zero, r minus 1. But A की power r is 0. Then A is called nilpotent matrix. Nilpotent matrix of index r. Nilpotency index r. And index r is always less than equal to 1. This is clear? Yes or no? Nilpotent matrix index is always less than equal to r. Done. Okay. Nilpotent index is less than equal to r. This is very much clear. The second point is if A is 5 cross 5 matrix such that A की power 4 is 0. Is it implies number 1, A is nilpotent? Second, A is nilpotent with index 4. Which of the following is true? कौन सा true है भाई? Yes. See, this is true, this is false. See, A की power 4 is given 0. It may be, see, going back, if A की power r is 0, then A की power r plus 1 is 0. A की power r plus 2 भी 0 होगा. हो सकता है a की पावर n भी जीरो, a की पावर n प्लस वन भी जीरो, सब जीरो हो जाएंगे. But if something is given like a की power n plus 1 0, a की power 5 0, a की power 3 0, it does not means that you will have a nilpotent matrix of index. Index you cannot define here because index it may be that a cube is 0, a cube is 0, then a4 is 0. So index you cannot say. But हाँ, nilpotent तो always होगी. Nilpotent is always. Done? Yes. You know, basically there is some confusion. One confusion. I think Sam already is asking that confusion. I have understood the problem what he is asking. Basically, like how to find out the possible eigenvalues. Basically, ax equal to lambda x gives possibility of eigenvalue. Yes or no? Possibilities of eigenvalue. Basically, when you do problem like idempotent matrix has eigenvalue only 0 1. Why? Not by this. Not by this. This is not characteristic polynomial. This is a characteristic polynomial. Can you tell me this is a characteristic polynomial of idempotent matrix? Lambda square minus 1. Lambda square minus lambda is a characteristic polynomial of idempotent matrix. No. कभी भी मैट्रिक्स को देख के अगर किसी ने कह दिया कि a square is equal to a, then this is a characteristic polynomial. No. This is a characteristic polynomial only of idempotent matrix of order 2. Order 2. Yes or no? If somebody say idempotent matrix of order 3, what is the characteristic polynomial? क्या आप ये क्या दोगे? नहीं पता. पता है? मुझे तो नहीं पता. Am I clear? Am I clear? Yes or no? So directly, है ना? Is it clear ना? So you cannot say like this. Okay. So basically, this will not give you eigenvalue directly. हाँ, but this problem ax equal to lambda x gives possibility of eigenvalue. मतलब जो eigenvalue आएंगी तो इसी फॉर्मूले से आएंगी. It means possibility. It means you can say like a square x equal to lambda square x. A square is ax is equal to lambda square x. Ax is lambda x is equal to lambda square x. It implies lambda square minus lambda of x equal to 0. X is non-zero. Lambda square minus lambda is 0. Lambda square minus lambda is 0. If lambda square minus lambda is 0, it means you have lambda is equal to 0 or 1. It means we can say possible eigenvalues of idempotent matrix belongs to set 0 1. मतलब ये नहीं है कि सारी eigenvalue यही होंगी. 0 1 are the eigenvalue. These are the possibilities. Eigenvalues possibility like multiplicity can be changed, but these are the eigenvalues. ठीक है ना? Multiplicity can be changed. So you can say identity matrix has eigenvalue idempotent at 1 1 1, and 0 is 0 0 0, and some other like lambda minus 0 lambda minus 1. This kind of you can have idempotent matrix. But this matrix, this theory give you the set of all possible eigenvalues. Done. So I am just telling you, student, if you have a problem, A is n cross n nilpotent matrix. Nilpotent matrix. Then ax equal to lambda x. A की power rx equal to lambda की power rx. Nilpotent matrix of index दे रखा है उसने, index equal to r. So can I say lambda की power r is equal to 0? Because a की power r is 0. So lambda is equal to 0. So lambda is 0 is only the possibility. मेरी बात समझ रहे हो? Lambda is equal to 0 is only the possibility of a nilpotent matrix. So it means nilpotent matrix की all eigenvalues, yes or no? Nilpotent matrix all eigenvalues are 0. Am I clear? Nilpotent matrix. Now second question is, I have said previously one thing. nilpotent matrix implies all eigenvalues are 0, but converse need not to be true. ये बात कही थी हमने. I think this is your problem, Syama Reddy. Yes or no? This is your problem. Yes or no? I think. Yes or no? मैंने पकड़ ली प्रॉब्लम. तुमने मुझे प्रॉब्लम बताई, मैं समझ गया और मैंने आपको बता दिया. This is the problem. See, if nilpotent matrix all eigenvalue 0, so lambda की power n is 0. Lambda की power n is a characteristic polynomial. Yes or no? Yes or no? All eigenvalue 0. I can give you guarantee. Yes. अब मैं प्रूफ कर रहा हूं. See, this is also true. This is also true. मैंने आज तक बताया नहीं आपको, but this is also true. Why? Nilpotent matrix all eigenvalues are 0. Let us consider all eigenvalue 0. A matrix है 5 cross 5, all eigenvalue 0. What is the characteristic polynomial? Characteristic polynomial. What is the characteristic polynomial? Lambda की power 5. And this characteristic polynomial is of nilpotent matrix. And so can we say that this is also nilpotent matrix? So we can say a matrix is nilpotent. A matrix is nilpotent if all eigenvalues are 0, and if all eigenvalues are 0, the matrix is nilpotent. क्या मेरी बात समझ में आ रही है? Yes. So Shyama Reddy, is it clear to you? The point is clear to you and all of the student. कि if eigenvalues की प्रॉब्लम भी क्लियर हो गई. Yes, very good. चलें आगे. Okay, done. So one more problem I am giving you on the basis of this problem. Let B is a matrix of P inverse A, P inverse, let P is 3 by 3, any non-singular matrix, such that B is equal to P inverse 0, 0, 0, 1, 0, 0, 0, 2, 0 of P. Then find, then number 1, determinant of B is 0, rank of B is equal to 2, and rank of B is 2. B square is 0, B cube is 0, B is nilpotent. बताना what is the options? Determinant of B is equal to determinant of P. So similar matrix, this is B and A are similar. B and A are similar. Similar matrix has same determinant, same rank. Yes or no? अच्छा तुमने ये नहीं सोचा कभी? अच्छा ये बताना what is A square? A square is A square. What is A square? A square is 0 या A cube is 0? बताना कौन सा करेक्ट है? A square is 0 या A cube is 0? A square 0 या A cube 0? Basically A is nilpotent matrix. A is nilpotent matrix. A square 0. एक बार चेक कर लो. Check once. No. A square is 0 na. So A square 0. It means B square is also 0. Because B square is equal to P inverse A square P. B square 0. And A cube 0, then B cube 0. And B is also called nilpotent. and with index 2. Am I clear? Am I clear to you? क्या सोच रहे हो? ए और बी लगा दिया, काम खत्म हो गया. एंड बी आर ऑप्शन, these are correct. See, these are correct, but these are not only the option which are correct. Just think in some diverse manner. Yes, and we have discussed all these things previously, and you are writing wrong answer. Why? You have to think. You have to think this way. Am I clear? Am I clear? Yes. So, can I say one thing? If A is nilpotent matrix, then B is equal to P inverse A. P is also nilpotent. Of same index. इंडेक्स भी सेम होगा. यस और नो? इंडेक्स कैसे चेंज हो जाएगा? इंडेक्स कैसे चेंज हो जाएगा? इंडेक्स इज आल्सो सेम. यस, सिमिलर मैट्रिक्स हैज सेम, सिमिलर मैट्रिक्स nilpotent has same index. ओके, यस और नो? भाई कुछ इंटरेस्ट आ रहा है? अब पढ़ाना बंद कर दें, ये पढ़ाएं अभी और? Do you want more questions? Like topic is now not complete till now. Topic is not completed because this topic has like you have asked me so many questions, so I have added some questions from my side also, so that you can understand in better way. So I think nilpotent matrix is clear. Algebraic multiplicity, geometric multiplicity is clear. Diagonalization is also clear. Nilpotent of all eigenvalue 0, this is also clear. Yes or no? The remaining part is, what are the different remaining part? Like one portion you were asking, block matrix. Block matrix. Block matrix. Any other problem you are facing in linear algebra, just tell me right now, so that we can discuss these problems tomorrow also. No? We will have a series, like some, I will understand how much time I have to devote this month. You want to discuss dual space? Dual space is not in our syllabus, but we will discuss dual space. Dual space is called set of home UV. Any other problem? Yes. Any other problem you want to discuss with me? Because we have 5 days for linear algebra. 5 days means Friday is over, Saturday is over, sorry, Thursday is over, Friday is over. So Sunday, Monday, Tuesday. Sunday, Monday, Tuesday. Tomorrow is Sunday, then Monday, then Tuesday. We will have 3 more classes of linear algebra. I will give you more and more problems which will clear your concepts, the most difficult problems, which will like drill your concepts, as well as this will activate your brain neurons, so that you will have. Can we have some more topics, and can we have some most important topics in vector space? See, vector space, you will tell me what kind of topic you want to discuss. See, vector space, subspace, and linear. Subspace is only the topic from which subspace basis dimension. Subspace basis dimension. If you have any problem in subspace basis dimension, we can discuss. First of all, theory. Then we will have question. We will have question. We will have from all the topics of linear algebra. Is it clear, Shivani? All the topics we will cover, like 3 days MCQs, most important. We will have all the questions. Okay, so if you have any particular topic problem, you can tell me. I think there is a problem of W intersection W1 problems, and this is also like कुछ इस type की problem थी. ठीक है. Direct sum is not in our syllabus. This kind of direct sum is not in our syllabus, but I will discuss little bit about this one also. Just any other problem you are facing? अच्छा, I just want to tell you one important problem also. Okay, see now after two problems, I will close this session, today's session, and these sessions are remaining. These sessions, third, 6, 7, 8, 9, 10, 11. We will discuss this topic tomorrow, and we will have question sessions also. Okay, but before ending up these questions, I am going to discuss some more most important question also. Okay, like this. Just understand. One more question. Okay. See, can I send my doubt? Yes, yes, doubt sheet you can send me your WhatsApp. WhatsApp, I will receive the WhatsApp. All of you can send me the doubts on WhatsApp. We will discuss on the class. Done? Yes. See. One question. You know periodic matrix? One thing you know rotation matrix. Done? Rotation matrix, you know, we have discussed a theta. This is, we have, I think, already discussed this thing. Rotation matrix. मैं जरा एक बार और लिख लेता हूँ. Idempotent. मुझे इसकी एक प्रॉब्लम बतानी है आपको. Idempotent. Rotation matrix, you know rotation matrix, you know geometric interpretation of the rotation matrix we have discussed earlier. Rotation is yes, this. Rotation matrix geometric interpretation, you know, yes or no? फटाफट बताइए. Don't waste my time. Also your time also. Like you have some point, like this is a point. You are rotating xy, like some angle. This is called rotation matrix. Yes or no? Like you have a point, rotation matrix, rotate. Okay, like that. Rotation matrix number 1. This is a orthogonal matrix. For all theta. This is true or false? Rotation matrix is an orthogonal matrix for all theta. This is true or false? You can find out a theta transpose. You will find out identity. It means rotation matrix has, this is a rotation matrix, and rotation matrix is always orthogonal. Is it clear? Yes or no? Is it clear? Yes or no? मेरी बात समझ में आ रही है? क्या चेक करा आपने? मैं चेक नहीं कर रहा. This is simple. The rotation matrix is always orthogonal. ठीक है? Our rotation matrix are always orthogonal. मैं बोलते क्यों नहीं हो आप लोग? All of you are like, मुझे ना पढ़ाने में इंटरेस्ट नहीं आता है. जब आप, if you have difficulty, you can tell me. If you don't have difficulty, I am asking, is it clear? So you have to say yes or no. Just tell me. Rotation matrix is clear. I am saying this is a rotation matrix. What is the meaning of rotation matrix? Basically, when we have done our geometry problems, we know that let us consider this is axis, x-axis, y-axis, and this is very important problem. That's why I am discussing. And you are rotating this axis. You are rotating the axis y dash x dash. Okay, if rotating axis by theta degree, so what you have done? The new coordinate is x dash, so x dash equal to x cos theta plus y sin theta, and y dash equal to x minus x sin theta plus y cos theta. Yes or no? So this is called x dash y dash is nothing but cos theta sin theta minus sin theta cos theta, and that is xy. So this matrix is called rotation matrix. Rotation matrix, what the rotation matrix does? Rotation matrix, if you have some coordinate system xy, and xy is a coordinate system with respect to this x-axis, y-axis, but when you see this same coordinate with respect to x dash y dash. So यहाँ से तो ऊपर चल रहा है first quadrant. If you see, this is the first quadrant with respect to x y. If you take x dash y dash, this is fourth quadrant. Yes or no? So it means the location is changing. It means the location changing. The location is given by this one. You know this one. Okay, I am saying this matrix is a orthogonal matrix. You can multiply A transpose. If you take A is equal to cos theta sin theta minus sin theta cos theta, and if you take A transpose, that will be identity. So I am saying this is a orthogonal matrix. If somebody say ki can you have orthogonal matrix of 2 cross 2, you can have infinitely many orthogonal matrix of 2 cross 2 because theta पे depend नहीं करता, theta पे depend नहीं करता. So you can have infinitely many 2 cross 2 orthogonal matrix. Is it clear? Orthogonal matrix are infinitely many. Orthogonal matrix are infinitely many of 2 cross 2 order. Very good. This is one of the wonderful problem. And the second is, if you say a theta 1 and a theta 2, if you multiply, just multiply, and I am just giving you the direct answer. Multiply, you will get this one. I think we have discussed this one earlier. Yes or no, student? We have discussed this one earlier. This, yes. So these are, so orthogonal matrices are always commutative. Orthogonal matrix, no orthogonal matrix. क्या कह रहा था मैं? Rotation matrix are always commutative because rotation matrix, you are saying rotate, you are rotating by, see, by this one then this one. Okay, या पहले आप ज्यादा एंगल ले लो फिर कम ले लो, the same thing. It means rotation matrices are always commutative. So rotation matrix is always orthogonal, and orthogonal means rotation matrix has eigenvalues. Rotation matrix always has determinant plus minus 1. Rotation matrix, but orthogonal matrix, orthogonal matrix has determinant plus minus 1. Orthogonal matrix are of type determinant plus minus 1, you know, but rotation matrix has determinant only 1 because cos square theta plus sin square theta. So rotation matrix is one kind of orthogonal matrix of 2 cross 2, that is cos theta sin theta minus sin theta cos theta. This is rotation matrix. This is commutative matrix. This is determinant 1. This is determinant 1. Determinant 1, and this is one of the wonderful problems. If somebody asks a question, a very good question, like let A is a nilpotent matrix. मेरी बात समझना जरा. Nilpotent matrix of order 5. Then index is less than equal to 5. Yes or no? This is true or false? This is true. But there is one more question. Let A is 5 cross A is, let us consider 2 cross 2 periodic matrix. Then periodic matrix A2 cross 2. Then period is always less than equal to n. Can I see this one? Period means A is non-zero matrix, we are saying. A की power k is equal to A की power k plus 1 is equal to A की power k. Then k is period. You know this thing, we have discussed already this thing. What is the meaning of period of matrix? Yes or no? So this is true. Yes, this is not true. Period आगे जा सकता है, nilpotency index आगे नहीं जा सकता. This problem we have generated a new problem. You will not find this problem in any book and Google and कहीं नहीं मिलेगी. ये प्रॉब्लम मैंने जनरेट करी थी, ये प्रॉब्लम सोची थी, and by the help of rotation matrix. Why? Because you can see you have a theta. This is a matrix. take theta is equal to 90 degree. What is the matrix? What is the period of this matrix? What is a square? A square निकालना क्या आएगा? What is a square? Yes or no? Yes or no? What is A4? Sorry, A cube. A cube is, what is A cube? What is A4? फटाफट बताइए. A4. Then A5 is it. Period is 4. So period can exceed the order of a matrix. Period can exceed the order of a matrix. Am I clear? Am I clear? Student, try to understand this concept. This is very wonderful concept. A4 is I and A cube is not something. A cube is something else. A5 is A. Period can exceed to the order, but nilpotency index cannot exceed to the order. This is a wonderful problem. Am I clear? Done. तो मैंने आपको पीरियोडिक मैट्रिक्स का बता दिया और रोटेशन बता दिया. एक मैट्रिक्स का बस आइडेम्पोटेंट का एक प्रॉब्लम रह गई जो मेरे माइंड में है, वो फिर नहीं तो निकल जाएगी. ठीक है, एक बार निकल गई. कुछ नई प्रॉब्लम मेरे दिमाग में है कि वी नो, देखना जरा, क्या ये आइडेम्पोटेंट है? इज इट आइडेम्पोटेंट? अच्छा, ए स्क्वायर निकालो. ए स्क्वायर क्या है? ठीक है, ए स्क्वायर क्या आएगा? यस और नो? ये प्रॉब्लम हमने जनरेट करी है एकदम. लिख दूं ये? So this matrix is not idempotent. But what about this matrix? अगर मैं ये लिख दूं, this is idempotent. If somebody is asking, actually, Chetan has asked, sir, there is a unique idempotent matrix if determinant is 1. I am giving you infinitely many idempotent matrix of determinant 0. See, what is this? This is idempotent matrix. Determinant 0. Yes. If I give you this problem, A is equal to 1 1 1 1 1 1 1 1. What is A square? I think 3 3 3 3 3 3 3 3 3. देखो ये आएगा. So can I write down that is 3 times of A? कुछ मतलब ऐसे लिख दिया मैंने. But this is wrong, na? See, wait, this is wrong. Our answer is wrong. Our answer is wrong, nahi? A square is 1 1 1. But we have to find out that this is not idempotent. You are saying this is yes, 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 yes. I am saying yes, you are saying yes. This is wrong. Right? This is not idempotent. This square is this A, but this is different. This is different. Yes or no? Actually, idempotent matrix, I am giving you series. This is not also idempotent. Previously, this is also not idempotent. Now, I am giving you, if you take this is idempotent. इफ यू टेक 3/3, चेक करो जरा, कैन आई से all these are idempotent matrix? चेक करो जरा, this is idempotent, yes or no? Yes or no? All these are idempotent matrix. These are very important problems which can be used in some problems, that's why I am saying please understand this problem. All these are idempotent matrix, and this is one of the most important problem, because you know this problem, this is very like easy problem ki if all entries are 1, you know all entries are 1, then you know this problem कि इसके अंदर इसका करेक्टरिस्टिक पॉलिनोमियल पता है मुझे, 0 आइगन वैल्यू आती है n-1 टाइम्स और n आइगन वैल्यूज आती है 1 टाइम्स. Yes or no? Yes or no? Am I clear? In this problem, if A is equal to Aij, the very famous problem, Aij equal to 1 for all ij, you know इस मैट्रिक्स की आइगन वैल्यूज 0 और 1 ही आएंगी. 0 की एल्जेब्राइक मल्टीप्लिसिटी है, दैट इज n-1. इज इट क्लियर? ये बात हमने डिस्कस कर चुके हैं. क्या ये बात हम डिस्कस कर चुके हैं? ऑलरेडी वी हैव डिस्कस दिस थिंग इन आवर प्रीवियस क्लासेस कि 1 1 1 1 1 1 1 1 आइगन वैल्यूज 0 has multiplicity m and n has this. Going back, if this is a problem, what is the eigen value of this? What is the eigen value of this? You will say, sir, if somebody is asking, this is a characteristic polynomial, सब कोई पूछने लगे इसका characteristic polynomial. This is idempotent matrix and characteristic polynomial. You can find out eigen values की आएगी, एक तो आएगी 1 और एक आएगी 0. 0 तो आएंगी because see, this is 1 by n times of, this is, you can say this problem is A is equal to 1 by n times of all these entry 1 1 1 1 1 1. So this has eigen value 0 and 1 n. So this eigen value has 0 and n into 1 by n, 1 and 0, and this has algebraic multiplicity, what is 1, and this is n-1. Am I clear? You can write down an idempotent matrix. This kind of problems can be asked. These are the new problems. Done? Is it clear to all of you, student? I think today we have done a lot of problems, and you have got some confidence. Yes, most of the problem of linear algebra you can do in IIT JAM 2022 exam. So I am just here to boost up your confidence. Please do hard work as much as you can. Don't do any kind of your household work. Just prepare, because this is the last time, the crucial time. अभी नहीं पढ़े तो कभी नहीं पढ़े, अभी सबको रिवाइज करके चलना है, अब तो दिन रात पढ़ना है, ठीक है? So please do hard work now. This is the main time. Don't do any kind of household work. Anybody. तो भाई आप कोई भी स्टूडेंट है, थोड़ा अपने टाइम को मैक्सिमाइज कीजिए पढ़ाई को, ठीक है? खुशबू आप भी थोड़ा समय जल्दी काम करके, जल्दी उठ के सुबह काम करके अपना पढ़ाई कीजिए, जिससे आप आगे बढ़ सको, ठीक है? एंड यू हैव मोर रिस्पॉन्सिबिलिटी, है ना? यस, चलिए.